platform is the organization of thematic events in which they can tell us the latest developments they have done in the research projects. Also, we organize networking activities, like a little bit like what Santiago has organized today in León. So they can get together and network a little bit and explore future collaborations. So we try to, at least in 2-year terms, organize a couple of events per vertical and horizontal line of interest. So you see here this event on nanotoxicity that we organized a couple of years ago. This one about materials for nuclear applications. We also support technological startups and spin-offs through the organization of events with investors in which they can present their technologies and their companies through pitch presentations. And we also have an open innovation platform in which companies can propose technological challenges, and then these technological challenges can have expressions of interest to be solved by other companies or technological centers or academic centers. I mean, all the stakeholders of the platform. Apart from this, we inform all the members of the platform about events related to the field of advanced materials and nanomaterials, calls that may be interesting for them, either from Spain, from Europe, or collaborative projects, bilateral collaborative projects between Spain and other countries. We inform them about collaboration opportunities, and for this we have a form in our website that you can all use when you're looking for a partner specifically for an event call. We inform about job offers, because we have two main stakeholders: the one that belong to the members of our members of the platform, and then through our social networks we have another group of stakeholders which are mostly comprised of PhD students or master students from universities and research centers that want to be in touch with the sectors. So learning about job offers is really interesting for them too. This year, well, from last year, we did a debate cycle focused on different verticals, on batteries, prosthetics, implants, mobility, and sustainable construction. And the goal here was to put together companies with academia, with technological centers, and also with the public administration to discuss about the challenges of each of these fields, and how what are the needs of the industry, how can the academic or technological sector contribute to solve those challenges, etc. And finally, the other thing that we do is the elaboration and participation in roadmap and thematic papers. Here you can see an example of some of the documents we have drafted since 2016. Several of them, you can find them in the library section of our website, and they even have versions in English in case you want to check them out. The last one we did is this one on the left, R&D goals and priorities from Waterplat, and I'm going to talk you a little bit about them, about this document. It was an update of our strategic roadmap that we did in 2017, and it gathers the contribution of 61 entities and 21 technological platforms and associations from Spain. So it has been a huge collaborative effort. And it took as a starting point the document published in 2017. So the document is divided into 5 different sections because it responds to how we were organized at that moment, which differs a little bit from how we are organized right now. So the 5 sections are transport, health, raw materials, smart cities, and energy. And the way the document is organized is the following. Each sector is divided into applications or fields. In this case, I'm showing the health sector because it's the shortest one. The other ones are very large. So the health sector is divided into medical devices, scaffolds, prostheses and implants, nanomaterials for therapy, and nanomaterials for diagnostics. So within each of these fields, we identified goals, objectives that are general. They don't have to be related specifically to materials. And then we go one level down and we identify technological challenges that are within these goals. And what you see below is our capacities, mainly capacities that Spanish entities can provide in order to address these challenges. So we have all the traceability of who wrote everything in the documents, in case you want to check it out and you want us to put you in touch with somebody with a given expertise. I mean, that's something that we can do for you. And then these are examples of how the other sections are divided. The transport sector is divided into aerospace, automotive, rail, maritime and infrastructure. In energy, we cover all the renewable energies, nuclear fission and fusion, energy storage, capture, transportation, storage uses, and transformation of CO2, hydrogen and fuel cells, so basically everything. Raw materials, we have polymers and composites, ceramics, metals, key minerals for industrial value chains. So I want to thank Santiago also for his huge contribution to this specific part of the document. Cement, textiles, nanomaterials, rubber, and naturally derived materials. In smart cities, it's a little bit kind of replicates some of the parts of the energy section because it cannot be completely dislocated from it. So we talk about energy, environment, sensors, urban buildings and infrastructure, ICT, and security. And one of the most important things, or one of the most interesting things to foster collaboration that we have in our website is our map of capacities. I told you that we have 248 members in the platform. So out of these 248, 237 institutions have their capacities implemented in this map. In a sheet that reflects this one that is shown in your right. So here you have general information from the company, entity type, the size, what topics this entity is interested in. You have contact information within companies and all kinds of institutions, type of materials in which the activity of the entity is based, what they can do with this type of materials. They can do prototyping, manufacturing, they can do simulation, whatever. And then below you have the specific technological aspects. And one thing that's very interesting is that you don't have to be exploring each of the capacities of the institutions separately. We have a filtering system, and for example, you can use as keyword silicon nanowires. So the system is going to filter you down all these 237 members down to which are the ones that have this specific capacity listed in their sheet. So it's a very interesting way to identify partners for specific collaborations. And the take-home message that we wanted to give you here is that we can be your connection to the Spanish R&D and AI materials ecosystem. Or you can find your partners yourself through our filter-based capacities map. And I didn't want to leave the occasion of presenting you a little bit of the institution that is behind Matterplat, which is the India Materials Institute. So I'm going to be very brief with this. In India are the Madrid Institute for Advanced Studies. It is a group of 7 institutes. We are independent institutions, but it is a network of institutes working in different fields, in water, nanoscience, software, food, energy, networks, and on materials. As I said, we are independent, but we are all promoted by the regional government of Madrid. In between the 7 of us, we gather more than 800 researchers from more than 40 nationalities. We have been created like in 2007. This year is our 15th anniversary. So all over these 15 years, we have done more than 1,500 R&D projects, and 3 of us, India Nanoscience, India Energy, and India Materials, hold these seals of excellence, Severo Ochoa and María de Maezu, which recognizes the top institutions in Spain working in R&D. So the goal of the Institute, or the mission of the Institute, is threefold: doing excellence in material science and engineering, attracting talented researchers from all over the world to work in Madrid, and then transfer this technology, the technology that we developed into the industry. We work on fundamental science, but oriented to the needs of the industry. And in terms of how we are organized, we have a board of trustees with 5 independent scientists from our scientific council that help us addressing new research lines, finding new researchers to join the institute and build up and establish new research groups. We have also the public administration, the regional government of Madrid, different universities from Madrid and the CSIC, and then we have companies. Currently we have Airbus, ITP Aero, Group Antolin, Repsol, and Dolsa. And these companies are here in principle to hold long-term collaborations with us. Regarding the institute, we have more or less around 120 researchers from 22 countries, and we have 15 staff researchers, each one with their own research group and research line. Most of the people have their PhDs in foreign countries, and since we are not a public, we are not a university, we cannot grant PhDs. Everybody that enrolls the institute in order to do a PhD have to enroll in a PhD program with a university. So 58 of the people is enrolled in foreign universities. And this is an image of our facilities. We have battery testing equipment, additive manufacturing for metals and composites, fire testing capacities, microscope facilities, a small but owned simulation or computing cluster, and we can do all kind of mechanical testing on materials. In terms of research, we are organizing in 4 different programs: novel materials, integrated computational materials engineering, multi-scale characterization of materials and processes, and also advanced manufacturing. And all of these, all the groups working in each of these programs, collaborate a lot with groups in the other ones, because the characterization in simulation are huge within the institute, so the experimental groups feed them with data in order to validate models and everything. And in terms of getting down to the research lines, our work is oriented to transport and industry, so working materials for extreme conditions. You see that we're working a lot with the aerospace sector, so that's extreme conditions per se. We work also in developing batteries for electrification transport, either batteries, structural energy storage in devices like structural supercapacitors, fire-safe batteries. We work on electrolytes. We have our first spin-off that works in anode materials for lithium-ion batteries. Originally we come from the structural world, so we work on lightweight materials, either composite materials or new alloys or hybrids or sandwich structures. We also work in Industry 4.0, meaning that we integrate sensoring and artificial intelligence and machine learning capacities to manufacturing processes, like, for example, resin transfer molding for composite materials. We work in 3D printing of metals, composites, polymers, using recycled fibers or recycled composite materials, and especially in metals. There's a lot of people working in metals, but our main expertise here is on powder design. There are a lot of materials that can be printed, but in order to withstand extreme conditions, not that many. So what we work in is in formulating new alloys and new powders. And in circular economy, we work with bio-based polymers, fibers, and additives in analyzing and reprocessing composite materials, etc. In energy, I told you in the previous slide that we work on materials for lithium-ion batteries. And regarding hydrogen technologies, we work a lot on in two main fields. One is discovering new materials that can storage hydrogen, and then in modeling and simulating the embrittling of metallic pipes or storage systems that have to store hydrogen, because hydrogen can diffuse over these metals. And then for CO2 capture, it is the same as in hydrogen. In health, this is a new line that has been opened in 2020, 2019. So mainly here we work on regenerative engineering, in bioresorbable 3D printing metallic and composite scaffolds, and also in hydrogels to promote cell culture and drug delivery, and also in using and including additives in PLA composite materials for 3D printing applications. And just to end, I told you that synthesis or simulation and characterization are huge within the institute. So what is special about what we do in characterization? We have huge capacities in microscopy and X-ray tomography, but what is interesting also is that we have a group that develop stages or devices to do mechanical, chemical, temperature testing, in situ testing of processes within the X-ray tomograph or the TEM. So we can see dynamic properties of materials. And in simulation, we work all the way from atomic structure to pieces, linking the results of each of the stages in order to keep the story of what happens at the atomic structure all the way up to structures. These are indicators that are not that relevant. We have been granted three ERCs, three Pathfinders. We are really good at getting Marie Curie postdocs grants. And this is the map of our current industrial collaborators. So you see that we have a lot of them through Europe, but also in China and the United States. And just to end, this a slide that we are really proud of, because everybody that does the PhD or comes as a postdoc to Indian Materials ends up either working in a top institution, in a top R&D institution in the world, or in top companies like ITP Aero, Airbus, Acciona, Boston Consulting Group, Siemens, Antolin. So people lands very good jobs after being at the Indian Materials Institute. So I hope you found this presentation interesting. I can share it with Santiago, so in case you wanted to take it a look with more detail, and you have my contact details just in case there's any doubt or you want to just introduce yourselves, explore any potential collaboration. So thank you very much.
Thank you so much, Eduardo, for your intervention. The next speaker will be Gregorio Mellugo, which is the Deputy Director of the FEA list and member of the Manufacture High-Level Group at NEFRA. Please, Gregorio, the floor is yours.
Hello, can you hear me?
Yep, perfectly.
Oh, wonderful. Okay, I was not sure about the sound. That's very good. And now can you see me as well? Can you see me? Yes, Hi, just checking if you can see and hear me.
Yes, I can hear you very well and see.
Okay, perfect. So the sound has come back. I take it very well. So I'm just going to share my my screen and. Okay, so sharing. Perfect. Can you see my computer screen now?
Gregorio, it is loading. We cannot see it.
Okay.
Yeah, yeah.
Okay, very well.
Maybe you can stop and try it again.
Yeah, sorry, I'm just having a bit of trouble hearing you now. Okay, can you confirm that that you can hear me well in any case?
Yes, the sound is well. Yep.
Okay, perfect. So let's get started. And thank you very much for inviting me today. I am very sad not to be able to join you in León, but nevertheless, as someone from the northwest of Spain, I am happy to welcome you to our region, and I am speaking to you from the south of Paris.
Gregorio, sorry to interrupt you. We cannot see your screen.
You cannot see.
Yep, no.
So let's see.
It's very loading, but it's not good.
What about now? Can we?
Now it's working. Yep.
Okay, and can we see the presentation?
Yes. now I think
perfect.
everything is okay. Yep. Please, the
All
floor
right.
is yours.
Wonderful, thank you very much. So I'm going to be making a short intervention. There we go. Now everything's plugged in. On the competitiveness of the European manufacturing industry and what's going on in terms of initiatives where SMEs can get involved. So what the panorama is in terms of how to weather the storm in a sense and how to capitalize on opportunities that are being brought forward by technological innovation and by globalization. Oh, can you next slide? I'm just checking that that everything's working properly. The next slide is visible. Thank you very much. Okay, so well, where am I speaking from? I am the head of a technology division within the French Atomic Energy Commission. It's a research center. So I head the artificial intelligence, robotics, and digital twin activities. So that's about 300 researchers. And our main mission is to work with industry. So we've got some 80 industry partners, most of them in manufacturing, and have so far spun off 11 companies from my division itself. So I am also a member of EFRA and the ManuFuture high-level group, so I'll be telling you a little bit about that in just a minute, and a member of the supervisory board of EIT Manufacturing, which is also an interesting initiative for European manufacturing SMEs. And finally, I'm also involved in ecosystem initiatives. I've contributed to the creation of 4 digital innovation hubs and managed one in the past, and also was part of the Paris Region Smart Industry Committee. So the things that I will be saying are coming both from a technology perspective, but also from an industrial ecosystem perspective. Relative to what's going on in Europe and where the next few years are going to take us collectively. And let's start with just a few words about manufacturing in Europe. And it varies from country to country, but in general, I think we're very good at Europe bashing in Europe regarding manufacturing and what it represents and where we stand in global competition today. So on average, manufacturing represents still 14% of European GDP, but more than 2/3 of the exports. And what's interesting is the main exports that make up this European competitiveness on the global scale are on transport. So that means it's complex products like aircraft or automobiles, and also in the machinery industry. So that represents about 33 million jobs today. However, and there is a big however, when you look at the fragmentation of the industry and the fact that there are actually 2 million companies in the manufacturing sector. So if you divide that, you look at the number of jobs and the number of companies, something doesn't add up. Well, the reality is that there are very, very, very many SMEs, and the panorama is not the same when you look into supply chains. But there's an opportunity there as well, because 3/4 of European SMEs practically are part of a large manufacturer's supply chain. The biggest problem that we have today, apart from our own fragmentation, is that in other regions of the world where things are more consolidated, they are making very, very big investments and bigger than anything that we have here in Europe, mainly in new technologies. And I'm talking about artificial intelligence, I'm talking about semiconductors. So these are supporting things. If you look at the electric vehicle industry, China is making very big strides, but in Europe, we're not so bad after all. So you could say that the game is not over yet. In any case, that we have got significant advantages, and we are still the high added value manufacturing hub in the world, but there are significant challenges that we still have not tackled completely. So If we look at the technology panorama, that's something that interests me particularly. We all know about Industry 4.0. So this is being put forward for the last, well, almost, I would say, 10 years, nearly as the newest industrial revolution. Bearing in mind that the first one was the one that we all know about with steam. Then the second revolution, it's on one side, energy changing to electricity, and on the other side, mass production. The third revolution, which took us to the early 2000s, was that of computer and automation and robotics. So that's what saw the robotization of the automobile industry. And where we are supposed to be today is that of cyber-physical systems. That means it's robotics, but it's also IoT, and it's the use of data. The use of data in companies to be more flexible. But where are we in reality? Well, actually, automation is still costly. It's not easy for an SME to make the investment to automate because the flexibility is not really there. It's not really there yet. And if there is a mistake, if the market changes, and we are in a more and more turbulent world, then that can make or break a company. The deployment of artificial intelligence is still far more limited than we care to admit. There is more and more control, so vision-based AI, and AI is being used in many parts of the chain, but the world of intelligent robots that can do whatever we tell them instantly is not there yet. And more interestingly, the data loops, so this gathering data with sensors and then using it to make something that have been promised, they are not fully used, and that's an understatement. In fact, they're not used at all. And today, 99% of data that is being generated with sensors and IoT and collected somewhere, it's not being used. It's not being put to use in anything. So the return on investment today is really not where it should be. Reshoring, so bring factories back to Europe, mass customization, and especially the benefits that this revolution was meant to bring to SMEs, they are definitely not where they should be yet. So what that made is, I think it was Gartner that said already 1.5 years ago that AI is sliding off the peak of the hype cycle. Everybody got really excited about it, and now we're really discovering the barriers and what we can do and what we cannot do. I'll just say to soften that somehow that we are talking about machine learning. Machine learning is the bulk of where the effort has been put in so far in artificial intelligence for industry. So that's where we are at today. You could say that the fourth industrial revolution is very European. We're not the only region in the world that has invested in that. We're not the only region in the world that has got large players like Siemens, like Bosch, Schneider Electric, that provide solutions. But the biggest players and the most successful ones in providing manufacturing technology all over the world are still today European, which should be a good thing. Just an interesting thing, I was asked to speak in Toulouse not too long ago about the parallels between the automation and robotization of the automobile industry and the aerospace industry. And since I saw that this was one of the themes of the day, I thought I would go back to that in a second. And the big question came from the aerospace domain. Well, why haven't we been able to automate manufacturing in aerospace more successfully? And if you look at the progression of the automobile industry, which of course many of you know about, the very first robot was deployed in a factory in the United States in 1961. I have to say, as someone in the nuclear side today, that this robot was directly adapted from a nuclear manipulation robot. So all the origins of industrial robotics actually come from the nuclear industry. Then it went very, very quickly, and car factories were automated progressively until the end of the 80s and beginning of the 1990s, where many factories, it was very difficult to actually see a person anywhere. But then what happened in the early 2000s was that companies had already begun to realize that this automation was very costly. That's not a problem if you get the productivity that you need on the other side, but especially that it wasn't flexible at all and that the timing and the costs involved were too high. So that's where the big outsourcing craze began to countries that had lower wages and that could actually automate less. And what's going on right now is that as technology advances and we can automate more than we used to, and automation becomes more flexible, we are coming back to a more hybrid, progressive robotization, where we use more collaborative robots, and we can combine productivity and cost effectiveness, changing capex into opex, and so we are getting robotized again, but differently. In the aerospace industry, there were a few problems, and if you look at aircraft manufacturing per se, the dimensions are just huge. So it would have had to be mobile robots in many instances. And if you look at the whole aerospace industry, including suppliers, production rates are lower. So the economic equation has not been there yet. The big driver for automation in aerospace, of course, is the fact that we need more accuracy and we need to be very, very high quality in what we produce. And what that meant is that in the 1990s and 2000s, there was a big drive for the introduction of special machines, which of course are very expensive, and we often found them only in manufacturers and tier ones. And a lot of the production still in lower layers is not fully automated. However, in both automotive and aircraft, we are seeing a change. And where is this change coming from? I like to refer to the situation at the end of 1970s. More concretely, warm afternoon in April 1978, when the first computer fair in the west coast of the United States was held, and you had Steve Jobs trying to sell his first Mac computer. We are actually beginning to see a different paradigm emerge, and I am talking about something that's begun a couple of years ago, and that is beginning to move the fortunes and the efforts of large industry players already. Not a lot, but on one side, the American GAFAM, and on the other side, big robot manufacturers in Europe. And what's happening, and what happened with the personal computer, is that there are quite a few technologies that are reaching a high maturity level at the same time, that if combined, can allow automation to become much more flexible, effortless, and require fewer competencies to automate. So that means less programming, that means less hardware changes when we need to change production. And what happened at the end of the 1970s is that a number of companies saw that if they actually encapsulated all of these technologies, they could deploy these computers that were a lot easier to use. What's happening now with polyarticulated robots in general, but it's also extended to machines that are more complex or more specific, is that we are seeing the possibility of automating with much faster engineering times, with lower sunken costs, and with more flexibility, even opening up the possibility of robots as a service, which has been tested so far, but in a limited fashion. So there are a few problems with this. If we manage to do that, then of course this is wonderful for SMEs, anywhere in the world. And because the investments that have to be made and the risks associated with investing in new technologies are going to be lower. But the technologies themselves are changing so fast that it is very difficult to actually make choices or even know which credible players are there. Just give you, but I will send over the slides if you want. At the end of the day, you can have that as well. A few examples of the technologies, both software and combined software and hardware that are coming together today. Not to talk about soft robots and other things that are going to come in the next decade. But what's going on is that there are a lot of efforts. Google, for example, has managed to hire a few of the top R&D managers in robotics companies in Europe to actually start their own business unit there last year. And trying to put into the market automation solutions that can actually change the game. I will not go into the applications, but basically what that makes is assembling is going to become much easier. So automating assembly, disassembly, so circular economy is going to be. This is going to become possible to reshore it, especially for high added value products, where we are sending things off outside Europe. And also that can make factories much more resilient to crises. Because if people cannot go to the factory or some things are missing and we need to adapt production, it becomes much easier to do. So I liken this to a wave. And the big question as a company is, where do we place ourselves in this wave? If we try too early before the entire industry is there to adopt these technologies, then it's very likely that we will waste our efforts, because it's impossible to stay abreast of everything that's going on. And to give you an example, the time it takes to turn a 3D scan into an exploitable model for a digital twin has gone down to a few hours, from a few hours, last year, to a few seconds a couple of weeks ago. So we are seeing very big changes in the time space of weeks. If you leave it for too late, of course, there is the risk of being submerged and not catching the wave. And then, of course, the interesting thing is staying in the wave, not too early, not too late. And how can one do that? Well, that's where innovation communities come into play. Being part of an ecosystem that is not just there to produce, but that has got as a worry, as a primary worry, what technologies to adopt, or what new standards can be deployed, and what can make a difference already in the companies that are in. And the European Commission is spending a lot of money and effort, and has been doing that for quite some years, in order to reinforce such ecosystems at European scale. And I am of the opinion that national ecosystems are still useful, they are still important, but unless we reason at European level, we will not be able to match what's going on in the United States and China in the coming years. And that would be a big wasted opportunity. So I'll give you a few pointers about what's out there in terms of organization, how to organize the ecosystem. And there is, for starters, the European Factories of the Future Research Association. And this association, it gathers industry partners, both big and small. It also puts around the table a lot of academic actors and research actors, such as the CEA ourselves. And the idea is to promote the development of and the adoption of new production technologies in Europe. So this association has been in place for a few years now, and it was the main partner for the European Commission to define the Factories of the Future program in Horizon 2020. So all these collaborative project calls in digitalization that we saw were discussed with member states, of course, for national priorities, but also with this community. So it's a community that where you pay membership fees. There are networking events and technology workshops, and they also elaborate strategic agendas. For example, there is a high-level group of which I am a part of that elaborated a couple of years ago the Vision 2030 for European manufacturing, and that's taken by the European Commission to actually define what programs are going to be launched. So in terms of how this is deployed in Europe, there is a partnership, used to be called Factories of the Future. The new one is called Made in Europe, and it's still in the early stages. There are public consultations going on, but essentially the European Commission is partnering with EFRA to define the agenda and down to the individual calls, proposals that are going to be deployed. So we're talking about several billion euros of investment. And I'm just giving a couple examples here of the next calls, which are going to be in artificial intelligence, data, and robotics, which were opened a few days ago, and they will close in November. But this is a cycle that's repeated every year, and now there is the 2023 program. So the type of projects that are carried out by the European Commission are both at upstream and downstream levels. So things that are interesting for SMEs are innovation actions. It's innovation actions where you can actually propose your company as a test bed or as a pilot for some of these technologies. And the interesting thing is that they have to be realistic, they have to be reasonably close to market. So that means that you can actually receive help, both financial and knowledge type, to look at the business case, for example, for introducing flexible robotics within the factory. If we look at another side of things that is also technology related, but that is putting a lot of effort into skills, so giving the digital skills to the population and also to companies themselves, that's the Digital Europe program. You might be aware of this program mainly because of the Digital Innovation Hubs initiative. There are also upskilling initiatives, and it focuses specifically on the diffusion of digital technology, so high performance computing, artificial intelligence. And the call that just closed was the one for testing and experimentation facilities for small and medium-sized companies. So what that means is that there are going to be a number of centers built around Europe where SMEs can test for free artificial intelligence technologies and what they would do on the factory floor for them. And they are meant to become experts at managing to deploy them successfully, given that there are significant regulatory barriers and such that it's going to be interesting. So this program is going to be running up until 2027. There is an investment of some over 7 billion euros. And it's something that companies can engage in individually or become part of the digital innovation hubs that have just been launched. And that's an interesting thing as well, because there are large industry companies that often participate in these initiatives. So it's possible to innovate with one's customers. And that becomes very interesting. And the last initiative that I wanted to talk about is EIT manufacturing, which you might be aware of. There are some Hungarian members already, but it's an innovation community, part of the European Institute of Innovation and Technology, that has received 450 million euros to actually work at the same time on upskilling, on bringing innovation to European factories, and on business creation and acceleration, so that means transformation of existing companies. And it was launched at the end of 2019. Today we have, I think we're closer to 70 members, but that's going to rise very fast because there's a new membership model here that makes it appealing for SMEs to join as full-time members. And the interesting thing here as well is that it's possible to capitalize on opportunities to run projects quickly. They are one-year projects usually, and very close to market. So there are things, for example, we have tested new end effectors in robots in agro-food factories in the north of Portugal. And we are able to bring together both SMEs, large industry groups, robot manufacturers such as KUKA and large integrators. So you can see that the topics that are being worked on, flexibility, environmental friendliness, and the place of humans in factories, that's something that's actually happening in all initiatives, whether they are at European level and even at national level today. So that's the end of my intervention. I think we're just about at 10:30. The key messages that I wanted to pass on to you today was that European manufacturing, of course, is still strong today, but we are fragmented and out-invested. And what we see very often in the outsourcing process, if the first reason to outsource was one of labor costs, which is very often the case, then the advantage is always temporary, and there will be someone coming afterwards. And what's important is that while the economic activity is going on in one region, what are we doing to create ecosystems where we have strong technology providers, where we have got a healthy digital innovation ecosystem that can actually strengthen SMEs and make large industry groups emerge in each of our regions. The second message is that the next technological revolution is already in motion, and you will be able to quote me on that, even if you think, no, it's still Industry 4.0. Actually, something different is already cooking. Some people call it Industry 5.0. I will not go so far. The global manufacturing landscape will change, and the type of companies that will operate in manufacturing are also going to change, or at least there will be new players coming in. And in such a turbulent landscape, also with the geopolitical uncertainty, with supply chain issues, the big problem in electronics today, it is key to be part of innovation communities where we can get the information and actually work with the people who will be our partners, our suppliers, and our customers. And that's it for me. I wish you a very pleasant day in León, and thank you again for inviting me.
Thank you very much, Gregorio. Thanks a lot also for the favor and for sharing with us all the initiatives. Looking forward to cooperate with you even more, because we already cooperate, but also in the framework of EIT manufacturing. And thanks a lot for so interesting presentation. Thank you, Gregorio. Have a nice day.
Goodbye.
Now it's time to give the floor to Dr. Claudio Testani. He is the Technology and Innovation Manager of APRE and also researcher at CALEF. CALEF is one of the interesting manufacturing centers and consortium center associated also to NE activity and to many activities in the region, in the center region of Italy. Thanks a lot, Claudio, for sharing with us your time. And the floor is yours. Thank you very much.
Thank you. Thank you very much, and thank you for your kind invitation. So I try to, let's say, share my screen. I hope to be able to do this. And so, I am ready to go. Please, can you confirm that you can see my screen?
Yes. Yes, we can. No los oye. Yes, we can, Claudio. Thank
Wonderful.
you.
Okay. So let me come back to the earth after the previous interview from Greg that really was very amazing, because we have seen what will expect us in the next, let me say, at least 10 years. So very, very amusing and very interesting. So coming back, I will give you some highlights. What is our experience in the CALEF consortium? That is a small, let me say, very small consortium of industries, companies, R&D and academies that is more focused on the prototyping and the manufacturing of components, not only for the aerospace industry. So if you see to the complete name of the CALEF is very long, a very long name, but in any case you can, let me say, take some highlights. We are speaking with welding, special technologies for welding, laser and electron beam. Then we are also speaking about application, process engineering and materials, and also technology of production. So this means that we are really, let me say, trespassing transversal application from the idea generation down to the real application on the market. This is our, let me say, wishes or our targets. We will speak, let me say, already I have seen also the other presenters that have explained their environment, and so I will do this about a consortium, just a glance, just to give you some ideas. Some project application example, and also we will pass very quickly to the conclusion. The Calef consortium is not only, it is also, I am speaking from Rome, so really we are in the center of Italy, but really we have companies and academies and R&D and also SME from all, let me say, all the Italy. If you think the pillars that are based, the consortium are 3 universities, Baric, University of Calabria and University of Salerno. Then we have also, obviously, the Enea, that is one of the main Italian research centers. That is a huge research center. And also the Italian Welding Institute. This is why our focus on the welding technologies. We have several SME that are, let me say, coupling with the laser technology, laser plant manufacturer technologies, and also, like for instance, SRS, that is an engineering society. Just they do design and they follow also the realization of the prototypes. Our, let me say, probably main engine is the larger industries like Alenia, Fiat, FCA, the research center, Fiat CRF, Ecor International, and also Walter Toto. So as you can see, we go to the very say huge and heavy plants for petrochemical, for instance, like to the very light that are the airplane and aerospace for Alenia Aeronautics. We are several plants, let me say, several main centers. Two of these are located in the south of Italy, in the Enea Trisaia Research Center, and also in Alenia Aeronautica with the Leonardo Pomigliano d'Arco plants. We are a small consortium, only 15 members, with specific knowledge, sectorial and multidisciplinary. And our, let me say, strong point is this. We focalize on a target, that means a project, and we try to propose for this project the right shareholder, that is a member of the consortium, for the right project, in the sense that in our, let me say, in our landscape, we can choose different competencies for the right and optimize the results for the right project. I must say that sometimes there is some overimposition of competencies, but these are, let me say, discussed within the consortium in order also to find further synergies. And this was really a winning point both for the Horizon 2020 and also actually for the Horizon Europe. Our main competencies are on the welding, let's say, special welding technologies, and in this case, electron beam. This is an old plant that is based here in Enea, but we will see also probably the newest electron beam plant that has been just placed in the Walter Tosto premises, but we will speak it about in a few slides. So, what are our competencies? As you can see, especially for the aerospace, we are competencies in the both titanium, steel, and also aluminum welding procedures that have been also for very thin thickness that have been qualified for aeronautic, let me say, application. Yes, these are two sources that are mainly for aeronautic purposes, but also the laser with a robot can be used for all the purposes that you want. University of Calabria has also the possibility to design and to modelize the component also for obviously finite element analysis, but this is interesting also for metallic foam that is not let's say easy or common. So we have made a lot of application with metallic foams inside the structure in order to validate their use for structural applications. And also for metal forming, this is a special skill again from University of Calabria, because this was really useful for not only for aerospace but also, you see, for naval application, in order to obtain and to validate the new and innovative process or manufacturing process that we want to apply. Obviously, the aeronautic was one of our hot points, and we have also collaborating in the manufacturing of the machine for the testing of airplane components, and this is some example in the Pomigliano Alenia premises. Our main, let me say, focus are the structural application of metallic materials. That means also the development, in some cases, of the new alloys, but it is an alloy design that is more focused with the academy's interest, obviously, because as you know, it's not easy to obtain also the certification of the same components, but just made with different alloys from the codes. That even if these alloys are higher properties with respect with those that has been certified for the flight. This is another point that is very interesting also to discuss for the future development in the innovative and new, let's say, real life applications. That is very interesting, but has still some, how can say, very strict requirements that must be always fulfilled. Otherwise, the authorities for the certification to flight never give you the green lights. The metal massive composite was, let me say, a real innovative point, but at the moment I must say that it's not so on the wave. So probably this is more a competence that we have, but not so on the way just now. Obviously, the nanotechnology is worldwide transversal application and technology. And then we have also competencies, as I have already said, in welding aluminum and titanium alloys, and we have a strong focus on the additive manufacturing for instance, both laser and electron beam technologies that are probably the new frontier, new border of our work in the next years. We have also experience in forging, high-speed machining that are, let's say, more the roles on our background. Pierre is one of our shareholders that is very skilled in the manufacturing of critical rotating components, such as impeller, inducers, leads, pen, and they do this for the aeronautic, large aeronautic manufacturer. Obviously, they are also, let me say, very, they can manufacture directly some assembly or larger assemblies for subsystems in the aerospace application. And also they are skilled in the production of lightweight components, especially the engine structures. Here you can find some example of these blades and are being compressor discs that are refractory alloys for the turbine and titanium alloys for the the compressor's last stage disc. These are probably more common components that we are used to manufacture, but these are in the two, let me say, more spread and nose alloys. One is for in aluminum, and one is titanium alloy. We have completed a lot of projects, and just passing very quickly because it's not very interesting, but just we are with Una Seal, we have completed the next tower project. It is not really a project for the aerospace, but is a project for innovative energy solar application, and we are working all with these other members. And also we have an ongoing project on the CO2 recycling, the capturing with the 80 raw materials authorities that we have just saying what is the focus on. We have during the years a special skill for the welding of the foam reinforced materials. That is very interesting because it's not easy to obtain let's say, sound welding without affecting the joining section with the metallic foam. And this was especially developed here in Enea Casaccia with some colleagues of Calef, and especially with the colleagues from Enea. Giuseppe Barbieri is one of these. For the hydrofoils, we have also, let me say, developed something that is just in the middle between the ship and the airplane application, because if you see, this could be really very could be exchanged with an airplane substructure, but is for high-speed ship, where the idea was to make more lighter the ribs for the hydrofoils, and this was made in collaboration with all the group of the consortium. In fact, you see, this is the real application of these hydrofoils, and this is a real component that has been made here in our laboratories. So it's very, let me say, an application that should be very proud of it. Also, for some real component manufacturer that we have introduced, the metallic foam was a success because they will be, let me say, you see the new structure with on the right, on the left, sorry, you have the old structure. This brings to a higher impact resistance structure, and also lighter solution. For aerospace, we claim the project Helios, in which we have manufactured some electron beam and laser beam components obtained by welding of some structural part that is not so complex, but this was you have to think that this part would obtain sometimes from the block, machining a block. So this brings to probably more than 40% time less in manufacturing, delivery, and also material saving. Also the drilling and the laser joining was developed for the aerospace, and these were also very simple parts, but sometimes they have high, let me say, cost because of the production of this needs a lot of times. All the result was a plant in which this part are manufactured, and this is one of the place where they also work with and have found transversal application for the automotive as well, for the automotive applications. One of our last member of the consortium is Egor International. This is also an interesting part because they have advanced mechanics food and beverage automatization for the food and beverage, and also aerospace and defense. This is interesting, and I would like to outline this because they have success in finding synergies between technologies that are, let me say, the same in these three different industrial sectors. And in this case, as you can see, they are specialized, they develop special components both for the, let's say, aerospace with very complex welding. For instance, in this case, three tubes that needs different sealing, full sealed weldings. And also they let's say apply this to very complex components for the high automatization of packaging, for instance, because the food industries need high speed and the high precision machines in order to let's say not have a high impact on the final cost of your brick of milk or a juice, for instance. Last but not least, butter toast. Butter toast, as you can see, is very skilled in manufacturing of very large, very large petrochemical components. They work in all worldwide, and they are just the past year opened probably one of the largest electron beam machine that have a vacuum chamber with this dimension that is reported 14 per 6.8 per 6.8 meters. This means that you have inside vacuum, you have a robot, you have electron beam welding that has the capability to build up real 3D, advanced 3D manufacturing components. Obviously, they can weld everything by electron beam that give you probably one of the higher quality of welding, as you well know. And so if you think this to a additive manufacturing machine, this is really impressive because can really produce very large components. So at the moment I am just arriving to the final discussion of our presentation. This is my project, the advanced materials. Sorry for my Italian, but I believe that you can read clearly. Is the innovative material for the aerospace, biomanufacturing, and the mobilities. In this case, this is an integrated laboratory which we have from the material design to the electron beam 3D printing, sintering, welding of complex part, and also autostatic pressing, so the post-processing approach. The last, let's say, point is also the check of the quality of this complex part that we have produced, for instance, by additive manufacturing. And this is a very large chamber, about 1 square meter cubic, that is atomography that can give you a real image of what are the defect or micro defect inside your part, also larger part. The last equipment that has been built is the autostatic pressing, and nothing of special, but is just to speak that we can also reduce the pores inside a ingot, for instance, and also because this is suited for the ultra rapid quenching. This means that you can just heat treat and completely finally heat treat the aluminum alloys. Obviously, we do also research, and we also, let me say, put some interesting heat treatment, especially for the additive manufacturing part made in 36 foam. So at this point, very quickly, we are also saving some minutes. I believe that the organizer will thank me for this, because CALEF is a hub for ideas and project development. In the sense, we are small, but we are very, let me say, efficiency in finding collaborative synergies between our members, and we also used to work with the other external, obviously, especially for the Europe, we are obliged to do this collaboration, and we also look for collaboration. And also, we, let me say, start from industrial needs that becomes application labs and also manufacturing for test infrastructure. This means that we are, let me say, most oriented in manufacturing prototypes and what all that this means from the design to the testing and also to the quality check. Okay, I believe that I have finished my presentation, and thank you very much again for your kind invitation.
Thank you very much, Claudio. Again, thanks for being here and sharing with you all these interesting activities. I'm looking forward to cooperate in the future. We already cooperated in the past a lot with Enea, and we launched several projects together, like Nest Tower in concentrated solar power. And in the past, we also were cooperating with Calef. I'm looking forward to see whether we can do an innovation ecosystem between Hungary, Italy, and Spain. Thanks a lot, Claudio.
Thank you very much, and all the best. Bye.
Bye, thank you. And now it's my pleasure to introduce you Mr. Néstor Coronado. Néstor has been Executive Director of Philips International. He has been also working as Business Director in EIT Raw Materials. And now he's also Manager of Value Loops, one company expert in circular economy. And he's going to give us an introduction on the circular economy and the European ecosystem of circular economy, how circular economy is important for all the manufacturing, advanced materials, aerospace technology, focusing on aerospace. Welcome, Néstor. Thanks a lot. The floor is yours.
Thank you, Santiago. Good morning, everyone. Well, first of all, I want to apologize for not being able to be in León. I had everything arranged to be there, and pitifully, with all the chaos that is in Amsterdam airport, I have missed the flight, and there were no other flights that could bring me to be with you there. Yeah, so my excuses, my apologies, but I hope I will be able to transfer a little bit of my experience and knowledge on circular economy today through this video conference. Can everybody hear me well, and can you see my screen? Can you see my screen?
Not yet, Nestor.
Not yet.
No.
Okay.
Can you try it again? After you open the box, you have to select the window. It is loading now.
Yeah.
Yeah, now it is.
Let me see if now it's showing.
Yeah, it works, yes.
It works. And
Yes.
now let me see if it works as well in the presentation mode.
Okay, yes.
Do you see presentation mode or not?
Yes, but we have the I don't know how to say it.
Next slide.
Yeah, we can see the next slide and the current slide.
Okay, so then this is not working, so I'm going to disconnect my own monitor, and I'm going to.
Now it works. Yeah.
Yes. Now
Yes.
can you see without my? The thing
Yes.
is, I see it probably different from you, but I do see my picture and all the different features of Zoom. Are you just seeing my slide?
We can see only the first slide, the circular economy in the European ecosystem title. You can.
Excellent.
I think you can start. Thank you.
Excellent. Okay, very good. Well, Yeah, let's start. So let me take you through this big opportunity, I would say, that we have with circular economy. And I will be focusing on circular economy as a business strategy. And probably you haven't heard that very often. Probably what you hear very often is about recycling, but I will not be focusing there, because circular economy has a lot more value when you look at the business strategy and how this can be implemented for manufacturing or for the aerospace industry. These are the topics that I will take you through. So first of all, a whole overview of circular economy, how this could be part of a business strategy, the link to manufacturing. I will be showing a video, so hopefully the technology will help us there to watch the video. It is 2 minutes, so it's not too long, and it's quite well done by an organization that you will see once the video is running. And then I will present you a little bit on the framework, how we could create a systematic approach, the challenges that circular economy face, and the benefits of circular economy. And I will be letting you know there as well that where the European Commission is focusing on, highlighting some wording, if you want, of the circular economy plan that they have. Since I may not be seeing you, if you have questions, please write them down, and I will be very happy to answer them at the end of the presentation. So what is actually circular economy? And this is my own definition, because I try to simplify all the wording that a lot of people use. So it is a business-driven approach that enables economic growth while decoupling it from resource consumption. The Ellen MacArthur Foundation, it is a think tank that has started, with this movement, and I had the pleasure to be part of that first journey when they started in around 2012, 2013. And together with McKinsey, which was the consultancy that we in Philips had for our business processes. So it was not about the business processes, and I raised one question then, saying, all the processes are linear, how can you help us making them circular? And so a little bit of what you will see now, it has the influence of those first interactions with the Ellen MacArthur Foundation and McKinsey at this time. I have put here for your reference as well the definition of the European Commission, which is very close to what I'm mentioning before. It just makes it, with more words, and since we are into the European context, I just wanted to highlight it here. Now, why do we need this transition? It's like the climate change, right? We have been saying already for years that we needed a transition, and we haven't done too much on the climate change overall. And now it's really, you really see snow during the summers in places where there should not be snow. You see floods, you see drought, you see a lot of events happening around the world, and people now may start believing. You believe when it comes close to it from TV or internet, it's far away, but when it comes close to you, then you start believing it. And I think circular economy is there to stay, and more we will see practices where we will enjoy it actually, reusing and closing the business loops rather than thinking that is second-hand, and I don't want to use that. One of the first trends that we see, and I want to put here, is Spotify, because in the past everybody would like to have, a CD, not to go back to the LPs. Probably in the audience you have some people that may remember the LPs, LP discs. It moved into the CDs, and actually after that everybody wanted to have an MP3. If you may remember that, and nowadays is Spotify, meaning that actually that the product itself is not relevant, but the access to what that product delivers is what is important. And that's why it became a success, because you have music wherever you are in different devices, not necessarily just one. And this is what circular economy aims for. It is providing access to the technology or to the features of that technology rather than to the product themselves. The second one is Facebook. Facebook, you will say, what has to do this with circular economy? Well, social media and access to the multi-channel world will help you create relationships. And with circular economy, what you need to have is relationships across the value chain to make sure that the products will have or will keep the value that they have as longer as possible with the highest quality as possible. And you need to manage those stakeholders. You need to communicate the power of the services that can be delivered by a product. And it is as well moving from a transaction perspective into a relationship perspective. So it's not just about buying something and that's it. It is about keeping that relationship with what you have bought, and not necessarily is physical. Like Spotify is not physical, Facebook is not physical. That relationship is what makes the activity meaningful, if you will. What we see as well as trends on the world is that the middle class is increasing, and mainly in Asia, but as well a little bit in Africa and Latin America, and it's huge. So it will be moving into billions of consumers that now may not have access to all the services that we have here in Europe, and they will be looking to have access to those services. So that will require a lot of consumption of resources that we might not have. So what do we do without all that demand, which is asking as well the highest quality and the best service as we are used here in Europe or in the developed countries. So that's putting a lot of stress on our resources. And these resources obviously are not infinite. They are limited, mainly when we talk about rare earth materials. We have been talking about the scarcity of critical raw materials. As Santiago has mentioned, I know that very well firsthand from the time I spent in EIT raw materials. And those materials are the agents to allow the transition either digital or what we call green, which is mainly related to renewable energies. If we don't have those critical raw materials, we will not be able to make those transitions, because simply the products or the enablers of the services that we're looking at cannot be produced, cannot be manufactured, cannot be made available for people. So we have an issue here with the resource availability, which puts obviously, a challenge for the pricing, because you see a lot of volatility on the prices, but not just volatility, but as well increase with the time to prices that probably will not be able to pay. So you will see that this will create as well a lot of tension in the markets. We see it now, for example, in the fuel market, which is still carbon dependent, but it will be the same for water, and it will be the same for critical raw materials or rare earth materials and so on. And that makes the whole economy very expensive. So we need to look at options of balancing and creating policies that would address these increases. And the end of these trends is big data. And it's probably one of the most important ones, because if we would be able to manage this amount of information that we have through the different means that are existing nowadays, and by all the sensors that we have, I think we would be able to definitely create more closed business loops as part of this circularity that we are talking about. Because if we would manage this information in a proper manner, we would be able to keep the products at the highest quality with the latest updates as much as possible, close to the consumer, close to the customers. And that will help us extend the life of the products, and therefore the access to the technology, and be a little bit less dependent on always creating new products from new resources. Now, I want you to have this in mind. Circular economy could be called closed business loops. Not closed because no one would access them. It's mainly that you keep them into cycles. Everything in life is a cycle. We are a cycle. We as human beings have been born and would die, and we will not be there for always. We have a day and we have a night. We have seasons, and everything is cyclical. Except the way we consume and the way we manufacture, we produce. And that's something that goes against, if you want, our nature. Therefore, it's important that when you are in a business, you start thinking since the very beginning, what is your strategy and how you will be able to close your business loops rather than keep contributing to a linear. This picture was, it's very simplified. There is another one more complex from the Ellen MacArthur Foundation, which was actually developed together with McKinsey, which is known as the butterfly picture, because it shows the technocycle in one side and the biocycle on the other one. However, since we are in a conference now on manufacturing and aerospace, I decided to keep it on the technocycle and to simplify that into this picture. As you see, you will see 4 R's there, there are different approaches, right? There are up to 10 R's that move from recycling and repairing, from repairing and refurbishing and remanufacturing to recycling. But this is just to simplify what we can do, and how at that time as well in Philips, we decided to focus on these 4 closed loops, together with enablers that you see there, which are 4 enablers. That was, again, nowadays are more enablers, but I wanted to keep it simple for this audience, because I believe these are the essential ones. Being design, collaboration, new business models, and reverse logistics. These are the 4 main enablers if you want to create a closed business loop, or if you want to start working concretely on circular economy. Now, all this is translated into money, and I will be not mentioning too much CO2 emissions, but it's obvious that CO2 emissions decrease is a consequence of the way you go with your business. Or increase, obviously, but here I would like to decrease those CO2 emissions, and therefore you will not see me very much preaching here about the environmental impact, because I do believe that if we solve the economical impact, the environmental impact would be for sure as well positively. The easiest loop that you can imagine, and a lot of people talk about, is the recycling loop. But this one has the least value. It is the lowest value of all what we can do, because all the features and all the added value that we have added to the materials, all the functionality that we have added, is lost, because we just go and focus on the materials. actually we should be not really putting a lot of efforts, if you want, on recycling, but as well on the business models, and trying to look at where the highest value is, which is normally closer to the user or to the customer or the consumer. And that's where the business strategy is important, because then you will probably, rather than sell, you would be leasing, or you would be renting, or you would be having agreements where the product would come back and you would get a discount. So there are a lot of different ways on how circular economy can be implemented. But obviously, the closer to the customer, the more difficult it is to implement, because it requires changes of the mindset, it requires changing of the processes, it requires as well changes on the economy at the largest scale, because if you think in a company, a lot of the value of the company is given by the share value. The share value, it's everybody wants to make a lot of money in a short period of time. So you need to start thinking that then the share value should not be on the short term, but should be on the long term, which could pose issues, you know, to a lot of companies that may be investing in large corporations. So that's why it's more difficult, because you will need a lot of different, you need to change the status quo on a lot of organizations and on a lot of systems that are existing right now, which are not enabling that closed loop, are not enabling the closed loop. So good to focus on recycling, but better to focus on a higher closed loops that can bring more value to society. Now, I wanted to put this picture mainly because when we talk about manufacturing, I would like to add a remanufacturing, because manufacturing is still, you know, something that we have used for decades. It is linear. Remanufacturing, it is doing the manufacturing again, and there are different opportunities. And this picture shows those opportunities, and I will go fast through them. One of them is the tracking of products that you can see on the left-hand side with number 1, the tracking of products through all life cycles. And that's, if you remember in the first slide, we have this big data. So big data is part of this and will help us understand how the products are used, where they are, and how they can be kept in the market as long as possible. The second one is optimizing the fleet efficiency. Optimizing the fleet, there is a lot of imbalance, for example, between China and Europe or the US, which are the largest economies. Because ships may go full loaded, and when they go back, they go empty. Could be the same with trucks. They go to one place full and they come back empty. So it is about understanding how we could optimize the use of the transportation means, but as well overall the capacity that we have to grow. Third is optimizing the routes. So there are different strategies on logistics to do that, where probably not always you need a truck to go up and back to hubs, but can do milk rounds, as they are called, where they go to different places in the neighborhood, and then they could go into a long haul. So there are different ways of doing that, using on the last mile, for example, electric vehicles, and so on. So optimizing the delivery routes, it is a big thing. Tracking products through, tracking products through the life cycle, so it comes again, because you need to keep doing that. Avoiding waste, which is the next one. Trying to, the same way in production, we have used this Six Sigma strategy, you know, or lean, those ones that are familiar with manufacturing. Six Sigma is mainly that, you know, you have products with the highest quality, so within 6 standard deviations. And I think we should probably use something like that when we use our products. So not just on the manufacturing side, but when we are using them and how we can have them optimally used. And then at the very end, recycling and sorting the materials, because we talk about a lot of recycling plastics nowadays. Pitifully, if you don't have a pure stream of plastics, meaning just PET or PP or PS, then you have an issue because you cannot recycle. So you need to separate, you need to sort the different type of plastics, and then you can recycle. So that will apply to a lot of other different materials. So that's why it's not just about recycling, it's really understanding what is the ecosystem and how we will be addressing that ecosystem in order to create those business loops that we're looking. I would like you now to look at a video, which is from Sesimo. It is. I decided to use this one. Because it talks on a lot of the elements that I have presented to you up until now, and it is quite short, quite to the point. So, guys in Leon, if you would be able to help me with the video, I would appreciate it.
I'm trying to broadcast this. Okay.
Do you want me to run it here on my computer, or you run it and should I stop presenting?
We cannot see your presentation right now because here in live we can see the video, so no problem, Nestor.
Okay, and for the people online?
They have the link in the chat. They can find it in the chat box.
Okay.
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 Sí, está en el chat.
So anyway, I'm going to run it now here for myself, because then I more or less know when you have finished.
A bicycle.
Okay. It is okay, Nestor, we can see it, okay? I'm not sure if you can also hear it or see it.
A bicycle, a microscope, an airplane. These and countless objects have a common origin. They were manufactured using machine tool technology. The machine tool industry is a key sector. It has a direct impact on European manufacturing and therefore in the transition to a more circular economy. Machine tools are durable. Many of them last over 20 years and then are completely refurbished. They are designed in a modular way, which helps maintenance, remanufacturing and disassembly at the end of their life. Moreover, around 83% of a machine tool is made of metallic materials, easily recyclable. The biggest environmental impact of machine tools is energy consumption during the use phase. To address this aspect, the sector has embarked in the development of international standards. Companies are also continuously researching new approaches for even better energy efficiency and performance. Their goal is to develop new manufacturing strategies to reduce energy and consumption of resources, while meeting customers' demands for improved quality and productivity. Digital technologies can play an important role too. They will help effective control of resource consumption and allow predictive maintenance. These technologies help to get quality products and extended lifetime of machine tools. Additive manufacturing is another technology that can support the circular economy. It allows to print spare parts on demand and carry out cost-effective repairs and remanufacturing. It can produce complex parts with lighter weight that can, for example, help the transport sector to save fuel. What else should the sector do? The machine tool sector should systematically implement circular economy principles, showcase best practices, and continue working on global industry-led standards. What should policymakers do? Policymakers should avoid one-size-fits-all approaches, support the digitization of European industry, support the development of new enabling technologies, fund research and provide incentives that can support a faster transition to the circular economy.
Okay, very good.
You can share again your presentation, Nestor.
Okay, excellent. Thank you. So I hope this video, has emphasized and highlighted some of the topics I was mentioning. And let me see. Can you see now my screen again?
Yes.
Yes, good. Okay, then I'm moving forward into the framework. There is a framework that I developed on how you do it, because I think sometimes we talk about the what, but not talk about the why, and that's how I started my conversation today, by taking you through the why. If you remember how I started with Spotify, Facebook, I ended up with big data. That was the why, the trends that we see, and how the economy is changing, and how they are fully suitable for circular economy. The what we have seen, but as well the how we are going to do it. So we can do it by, first of all, identifying the value. There is a tool for that, and there are different formats, templates, ways of identifying that value that are available. And the best is to do it at the concept level, at the design, or when the business is defining its strategy. The next part is to create a value. So to create a value either with products or with services or solutions. These are different stuff. When we look at products, well, normally a lot of them are manufactured, but some of the services not necessarily are manufactured, and the solutions could be a combination of all of them. I would say that, for example, Spotify is a service, but could be a solution is through, if you use Spotify, for example, for helping people with dementia, that when they listen to music, they will be remembering what has happened in the past in their lives. It could be for teaching. Then that service becomes a solution when it's integrated with other activities. So that's how then you create that value, and then you need to capture that value. So capturing the value means, as I was mentioning, moving from ownership to access. And that's what you want. You want to build up partnerships across the value chain, because you may not be able to do that independently. And you need to have a good visibility on where is that value, how that value is behaving, and where you can bring that value afterwards. And that was a little bit of the track and tracing that we have seen before. But as well, it's definitely very much depending on the business models that you are using. And then last, which I don't know, now is working, is sustain that value. And not necessarily from sustainability, but actually it comes from that term, right? How you take it through the time with you, and that's with typical practices that I'm sure you're very familiar with, like repair, maintenance, upgrades, refurbishing, remanufacturing, parts harvesting, and so on. So these are activities that will definitely help us keep the product, services, and solutions as much as possible in the market. And therefore, decoupling that growth that we all want from the use of resources, or the use of new resources. Now, in order to capture those opportunities, you need to have a systematic approach, and you need to have a long-term commitment. As I was mentioning before with the shareholder values, it's not about short-term, it's about long-term. And when we said, and we talk about enablers for design, what is design? Well, there are approaches, right, that are called, for example, design for excellence, design for manufacturing, design for logistics, design for residual value, design for reuse. So again, since the very beginning, the best is to design products, services, and solutions for closed business flows, rather than just thinking at the end, oh, by the way, we're going to recycle, which is completely the wrong approach. you can definitely recycle, and we should be doing it. But once we have completely exploited all the potential, all the value that we have created of that device, and the materials, obviously, that are part of that. Platforms, module approach, and material selection are quite important. For example, lithium battery. Nowadays, lithium-ion batteries are, everybody wants them without understanding that lithium-ion, it doesn't exist like oxygen. So it's scarce, it's not everywhere. You need to transport it. You need to process it into a very complex manner to build up the batteries that will not last for more than 10 years, So their capacity, their performance will decrease. So we need to understand, okay, why have we selected lithium-ion? And I know there are a lot of good reasons why we have selected lithium-ion, but it's just an example of saying, okay, when you select materials, you need to think on all the consequences of that, not because it's going to deliver the best performance in the short term, but what does it mean for the society? What does it mean for the user? What does it mean for the environment, and so on. Reverse logistics. I think we have talked a little bit about the smart logistics, but I would like to talk about the incentives and the legislation. I think this is where governments and as well sales organizations can work better in order to bring products back. The same we have nowadays, that you have next day delivery. So within 24 hours, you buy something in Amazon or in any eBay or any of these big platforms, and you have it next day. We should have the same day when you don't like, and that next day would be back. And actually, you will have a certification that will not be scrapped, that will not be recycled immediately, but probably will have a second life, which would be the best for that product. New business models, I have mentioned that, so more service oriented and performance oriented and solution oriented business models, which will provide us that access that all the new middle class people would like to have too, and collaboration. All this is not possible if we don't have collaboration between the different parties, the different stakeholders into the value chains, with long-term commitments as well. It's not just collaboration in the short term, but mainly collaboration in the long term. Now, this was, since our forum today is mainly talking about manufacturing, it was just, again, to share how a machinery producer can implement this into their own operations. So if you start on the left, you have the produce new product here. And normally, and this is, again, very simple. There are a lot of other ways to do it. I try to simplify to try to convey a message here. So either you sell it, which is the transaction, or you lease it, which is the access, or you rent it. And then you buy back. If you have sold it, you will need to buy it back. If you have leased it, you don't buy it back, you would get it back, right? Because it's still on your ownership. Once you have done these two, then you can do not just a visual inspection or functional inspection, you can do a lot of different things to determine what is going to be the next loop. It could be recycling if the product, for example, has been, it's a car that has been there for 50 years, or it has been, and it has, let's say, 200,000 kilometers, or it has been there for 5 years, and it has 300,000 kilometers. So it is always not just in terms of time, when you need to make the decisions, how old something is, but how much it has been used. What is the quality of it? So there are a lot of different aspects that you need to consider when making these closed-loop decisions. But indeed, it could be once recycling if there is not added value anymore that you can use. Refurbishing is one of them, and the reuse of components is the other one. And in this way, then you would be closing the loops. Now, the industry, just to mention here, the industries that have used these simple two examples is aerospace. Actually, you guys that are in aerospace should be very familiar with this because mainly the producers of Boeing and Airbus, the same as those ones producing engines like Rolls-Royce or General Electric, they have been refurbishing the engines and the planes for years. It is the first industry that have started to use closed loops, if you want, for their components, and actually for the whole product, which is an airplane. After that, I would say the ICT industry, so computers have done that, but as well, and mainly at component level, lately more at product level, but as well photocopiers. Photocopiers was one of the big industries that actually moved into leasing, and now what you want is to have the best photocopy on your desk rather than having the best photocopier. The photocopier would have been a device used already in the market for 10, 12 years, but you don't care about that. You care about the outcome, and the outcome is a photocopy. And that's another industry, the photocopiers that have been already for several years. They have changed their business model, and then actually now the business model is on the amount of prints, that you would have. So big corporations say, okay, I'm estimating to print 1,000 sheets per month, and that's how the business will go. I'm not saying that we should keep printing. And obviously, it's better if you don't print because then you don't use paper, you don't use ink. However, if you need to print, I'm just mentioning that for the business model of photocopiers, how this has been evolving, and what's important was to move from the product itself, so the photocopier, into the outcome of it, which is the photo. Now, I want to be very short on the right-hand side, but very critical here. This is a picture from PricewaterhouseCoopers, and I completely disagree with what is on the right, because from my own practice, the revealed savings can be more than the 15%. It would go in terms of value, probably around the 50%, and when it comes to the components that you can reuse, is 80%. And I have done that. So I have, there is in the market a machine that is doing imaging systems, right? So MRs, magnetic resonance, or computerized tomography, or X-rays of your body that have 80% of reused components. And it's the same probably for in other industries. But this one, I tell it for sure because I have done it. So the value is maybe lower because remember, you have, one thing is the components, and each component would have different values. So there are components that may have larger values than others. So components can go up to 80%. The value could differ, and as I was saying, could probably go around 50%. So I disagree with this because I think it is extremely low, and it will vary per industry. So the aerospace industry would be different from the healthcare industry, and that would be different from the IC industry and so on. But the opportunities that we have on the reuse of components, it's enormous. It's quite big. I want to mention here as well, in terms of manufacturing, I know you need to deal with compliance. I know you need to regulatory, with certifications, with quality. However, it is proven that used components can perform as good as new ones if you put them into the tests. And I want to say as well that the dynamics per industry are different. For example, the car industry, which has been doing a lot of refurbishing for a long time, probably for 40 years or something like that, same as the aerospace industry. The automotive industry just do it at component level. They up until now, the automotive industry hasn't done it at the whole product level, the whole car. They do it at component. While it's different for the aerospace industry or different for the photocopier industry, which both have done it at the whole product or system level when you have a complex product like an airplane. Now, almost there to conclude. This is before my last slide. What are the challenges? You can read them. I'm just going to mention two of them. So it is, if you want to make any change, it is important that the people making the decisions own the profit and loss accounts. Because if they don't own the profit and loss account, things will not change. And I'm going to be here very clear. So we talk about sustainability. Sustainability is a function. And a function cannot make business decisions. If we would be able to embed and to integrate sustainability KPIs or metrics into the profit and loss accounts, into the performance of the business, then we could make a difference. If we just based our difference on reports, it's not going to help. We need to embed whatever indicator that we have, which is an environmental indicator, a social indicator, or a business indicator, as part of that business KPIs driving your profit and loss. Otherwise, it won't work. And then the other one is on moving from delivering boxes into delivering services and solutions. I think we will see that a lot more in the years to come. That's why I wanted to start with music, with Spotify. Obviously, you cannot, here we have an engine of an airplane, you cannot change that. But you need to think, okay, what do we mean by moving boxes into service and solutions? Obviously, whenever it's possible. Yeah, and that's just something to think on your strategies. In terms of governments, well, I think in the Netherlands, where I'm based, I think they have been doing a quite good effort. I don't know if in Spain or Hungary or in any other country where you are, how the government has reacted to this, but there is a threshold on all the public procurement to buy used products or services. So I think governments can do that by establishing policies on their procurement. But as well, very important is governments can do something with the VAT. It is not fair that new products that have paid already the VAT, or that you will have paid the VAT for new products, you will need to have to pay the same VAT for another product that it has been used. It's the value add tax, that's the VAT, the value add tax. So you have paid for that value add. So there is no reason why you should need to pay again. So probably you need to pay the reprocessing. And it could depend if it's a recondition, or if it's a refurbish, or if it's a remanufacturing tool. But paying again the whole VAT, I don't think is a fair practice. These are areas where the government definitely support this transition. And obviously, industries using system thinking, as I was saying as well before, one of the enablers is collaboration. So we need to think on even beyond our industries, because things that can not be used on our industry anymore can be used on another one. For example, imaging systems for operations in operation rooms need to have a very high sharpness, extremely high sharpness, that even probably your eyes may not be able to see. And after a certain period of time, normally 3 to 5 years, they need to be discontinued for that purpose, and then they could be used in another purpose. So rather than recycling those monitors, they could go to people, monitoring a street or monitoring a process. They could go to other industries where that sharpness may not be needed, and the product actually has not been touched. It's just that it has been used, and it may not be fulfilling the requirements of that industry, but can definitely fulfill the requirements of another industry. So really thinking at system level is quite relevant. This is my last slide. With this slide, I would like to finish. And well, let me just go on the right. So on the right is a new circular economy action plan. This is the latest plan from the Commission. Actually, let me see if I can bring you there. Yeah, I can bring you there. Sorry that it's not bigger. That one, hopefully you can read, but I just wanted to mention some of the, let me see if I can make it. No, I cannot make it bigger because then you lose. So hopefully you can see and read now what the Commission says and the principles that were shown on the video that you have seen and the principles that I have been talking about, circularity, which is durability, reusability, upgradability, the efficiency of the energy and the resources used, the avoidance of hazardous substances, but as well, remanufacturing, high quality for recycling, looking at the footprints, at the carbon footprints, avoiding premature obsolescence. In some industries, this has been the practice because what they think is, I can reduce the value, so I can reduce the price. And it doesn't matter if they will need to buy it again in a year. Actually, the consumer or the customer doesn't mind or may not care, which is a trap because the price is quite lower. So sometimes we don't have, the money to pay the real value, and we say, well, okay, so in a year time we will see. I think this is a responsibility of all of us. Those ones not buying those cheap products that may last just a couple of days or a couple of months. And for the producer ones, obviously, making sure that the specifications and the quality of the product that you are putting into the market has the best quality and will last as long as possible with the right updates, with the right upgrades to avoid that obsolescence as well. And then, obviously, other things that avoid destruction of unsold durable goods. That's something that happens very often on the textile industry. Which is a stupid practice, and so on. So you can read by yourself the others, but I think it is quite important to look at these principles and address them. Let me see, because I have lost here my presentation, so then we can go to presentation. You can see the presentation again. Yeah. Okay. So. The benefits is that we would see an increase on revenue, so there would be growth. The product life cycles would be extended. The business strategies would be changed by integrating these business models that will increase revenues and will expand the life of the products. The second one is additional revenues, thanks as well to trading or return, which is linked to the increased revenues. Faster research and development designs, because if you do modular design, for example, you would be able to kind of copy-paste, if you want, from previous products, so what's called platforms. There are products that you have different screws, for example, depending on the version of the product. Why we don't use the same screws? Or like, as you know, there is a big buzz lately on the USB connections. I mean, the USB connections in the past, well, we had different, and the way we would be charging devices, everybody had their own charges, their own connection. Why we don't standardize that and we use one? So it looks like the Commission now has put a step on it, and we are going to change that. But this is a single example. Obviously, we can do this very broad, and we could help the whole society, we could help the whole ecosystem where we are into to move into closed business loops. The next one is moving, from CapEx, so which is capital expenditures, into operational expenditures. So you don't necessarily need always to invest and buy new things. So, and this would help us build access to emerging markets. Remember that the largest growth is going to be on emerging markets. It's not going to be on the developed world due to different reasons that you know. And that's something we need to consider. Even if the legislation is not enabling these transitions on the proper manner. We need to keep the highest standards, the high policies that we have in the developed world as well for the developing world. And obviously then focusing, because of the capital and OpEx on services and the functionality rather than on the position of the equipment. And the last is a cost reduction. All this will drive a cost reduction in the bill of material, in the supply chain, but as well in the customer service. So I hope with this I have give you an overview, but as well have motivated you to increase the closed business loops that you have in your organizations. I have started with the why, have moved into the what's and the how. I have given you some tips, have addressed as well other organizations that talk about this and what they are suggesting. I have created a little bit of discussions as well on for example, what PricewaterhouseCoopers says, and we need to put things in perspective. They may be probably referring to a specific industry, which it could be different for another. And yeah, I want to thank you for your attention, and I'm happy to answer any question that you might have. Thank you.
Million thanks, Nestor. Very clear, crystal clear, all the presentation. So thanks a lot. It's time to rest. Let's take a short break and some coffee. Thanks again for the speakers. We will reconnect in 15-20 minutes back, and we will, well, around maybe let's say 12:10, okay? Because we were expecting to have half an hour of as a break. We will try to extend at least to have 15 minutes, 20 minutes. And also, I will invite the people present. We are going to make a group picture downstairs. So please keep connected, and we will be back in about 15-20 minutes. Thank you. Okay.
Thank you.
Tamas, when you want, you can start.
Okay, thank you. I'll try to share my screen. Can you see?
Yes, but not in full mode yet.
Yes. So, thank you for the invitation for this nice event. It's a pleasure to be here. I have so many different type of roles in Hungary, but now I'm going to introduce the Hungarian Space Cluster as president of this organization. Here are the topics I want to highlight today. A few words about the history, the mission, what is the organization of the cluster itself.
Recording in progress.
What are our competencies, the members, and if we have some time at the end of the presentation, I'm going to say some words about some success stories from the past and the present. So started with the history, it's really important to highlight what is the relation between Hungary and the European Space Agency as the most important space organization in Europe. We started the discussion with ESA back to 2003 when the Hungarian government signed the PEX contract with the ESA, and we had to wait 12 more years to be a full member of the European Space Agency. It was in 2015. But during this 12 years, the Hungarian space actors recognized that the kind of organization would be nice to establish in order to make the visible the competence of the members and in order to give advice to the Hungarian decision makers. And 2007 was the year when the Hungarian Space Cluster, so-called home space, was established by 15 members. The mission of the cluster is, or the strategy of the cluster is that we try to bring together the Hungarian space actors, the actors who have significant role in the Hungarian space ecosystem, and the actors who want to be part of this ecosystem. We think that it's also really important to make the visibility of these actors because they are small. Most of the members are small and medium enterprises, and from this point of view it's really important to support them to access to the space market. And we try to organize networks and we give advice to the Hungarian decision makers. According to the organization, here you can see a flow. I am the president, and there are some responsible board members in the clusters, and I think not the name of the person is important, but what are the domains they are represent. We have an Earth observation domain, a human spaceflight domain, a CubeSat domain, an education domain, a general industry domain, a science domain, and of course we have a back office represented by someone. According to the competence of the cluster itself, we are focusing on the satellite domain within the space business, so we are not really favored with the launcher and the ground station segment. But within the satellite domain, we are working mostly on the upstream activities, but we have actors in the downstream. When we are talking about the downstream competencies, we need to focus on the Earth observation. Concerning the upstream segment, we can offer different competencies on the flight segment, on the ground support equipment as well, and of course, because it's a really innovative area, lots of research activities and projects have been implemented by the cluster members. Regarding the R&D activities, we're really focusing on the materials and the technologies, some ferry development, coating, composite development, and some laser, nano, and chemistry technologies are the key elements of the cluster activities. When we are talking about the flight activities, we can offer mostly structural, thermal, and electronic components to big, mostly science missions. And of course, we have a member who are really familiar with the CubeSat activities, from the mission planning to the launch and the operation activities as well. So we can cover all the mission activities. Within the cluster, there is a kind of hierarchy between the members. So it means that at the top of the pyramid, there are the primes. There are two companies are here, and we have a definition who can be a prime. The prime, there are two requirements to be fulfilled by a company. First of all, the company needs to be able to get project from ESA or some other international big entities. So they have to be able to submit a proposal that will be selected by the customer. But on the other hand, the other requirement is that they need to share the workload for other entities. So they do not need to do all the works alone. They have to be capable to organize a kind of consortium or supply chain. So they need to be a kind of customer for other Hungarian or not Hungarian entities. The second layer of the cluster are the R&D players. There are much more entities here. They have direct link and direct contract with the international space actors, but they do not need to organize a team. They are working alone. Of course, they cooperate with others, but it's not necessary, and this is not the normal way of their activities. The third layer of the members are the suppliers. They are professional in such kind of areas, but they are working not only on the aerospace sector, they support for example, the automotive, on the energetic sector or whatever else. They have a really professional machine park or something like that. They have well-known procedures, and they can be a supplier of the Hungarian prime, and sometimes in the R&D actors in the Hungarian space clusters. We can think about CNC milling, a special surface treatment activity or something like that, but they are not contracted directly from or by the international space actors. And we have a really good support activity for the science and the education activities. One of our members is our county chamber, two universities, University of Miskolc, you know well them, and Budapest University of Technology and Economics. The GFK is an astronomy research institute, and we have a foundation as a member in our network. Here you can see a snapshot about the activities, what we are doing. We think that the representation is quite important, so we participate in the Industry Space Days in ESTEC, organized by the European Space Agency, and sometimes we have a booth on the Space Tech Expo in Bremen in Germany as well, and we represent all the members, all the cluster members in this event. We are organizing networking events. We have monitoring activities, mostly the ESA tender monitoring, and when we observe or when we realize something that can be interesting for the members, we share the information for the members, and we support them in the tendering process as well upon their request. We try to collaborate and organize large R&D and industrial projects. You will see some example. Big space project that has a member from the Space, and there are some other actors from the Hungarian Space Cluster. We started to organize a training program because we think that the human resource supply is one of the most important things in Hungary. the first space engineering education will start in September, but we need real professional people to be part of this space community. That's the reason why we started to organize the Han Space Academy. We are waiting for the funding of the Hungarian Foreign and Trade Ministry, but we asked international level experts to be a trainer in this program. We are supporting the Hungarian ESA delegation. For example, myself, I am one of the advisors of the Industrial Policy Committee in ESA. We support the Department of Space Activities in the Hungarian Ministry of Foreign Affairs and Trade. These are the key organizations in Hungary who organizing everything in Hungary and who represent all the Hungarian intention at international level. We have a cooperation with the University of Miskolc. We try to support their intention to start the space engineering education next September at MSc level. The Han Space is member of the SMF4 Space. It's an organization of organization. The headquarters in Belgium, and they are well integrated into the ESA different type of boards. So we can get information through the SMF4 Space, and it's really important that we can represent ourselves and our intention through the SMF4 Space organization. We have an agreement with the Design Terminal. It's a Hungarian organization who is responsible for the Business Incubation Center. It's an ESA program. I don't know what is the deadline for me. So what's the time limitation for me? But if you don't mind, and if you have some more time, I can introduce some success stories from the life of the Hungarian Space Cluster.
We are with, sorry to interrupt you, we are with a bit of delay, but you can continue 5 minutes more.
Okay, I try to be fast. So my company Almatis has significant results in the Sentinel-2 satellite when we supported the thousands of thermal and structural elements directly to Airbus. Now we are working to CO2M mission. It's one of the Copernicus mission where the full payload thermal subsystem under our responsibility. We are working in the Ariel mission. It's a medium class ESA scientific mission where a quite large set of mechanical ground support equipment is under responsibility, and for the flight hardware we are developing the radiator that is sitting on the top of the satellite, and it is responsible for the thermal stability of the detector and the front-end electronics. We are working on the Comet Interceptor satellite, the COCA instrument, the Comet camera, where the full thermal subsystem is under responsibility. We delivered a multi-layer insulation for the JUICE mission. It is a satellite that will fly to the Jupiter for scientific measurement, and we developed the CHEOPS radiators that are in orbit since 2019. We have significant contribution to the Mars program because the Mars Return Orbiter, the Earth Return Orbiter satellite, there will be 2 scientific experiments on this, and one of them is definitely Hungarian. It's a dosimeter, and we are responsible for the thermal and structural design of it. The Ariel, here you can see some example of the NGSs. According to the CubeSat activities, the C3S company has the Red Cube project that was launched 3 years ago, and it is operated really well, and they are working on 3 different other type of cubes, video, grid and oval, for different customer. And here you can see the TRL levels and the planned mission. And the GFK, it's an astronomy institution, They are designed and developed their own CubeSat that was launched last year, and it is for detection of gamma radiation, gamma photon intrusion. Also, the GFK, they are part of most of the European and in some American astronomy program from the scientific side, and it's really important for us because they are part of the scientific team and the consortium. They can inform us as the industrial potential contributors that what are the opportunities at payload level. We have four different programs in the Honor program. It's a Hungarian astronaut program. There's a Hungarian intention that in 2024 or 2025, a Hungarian astronaut will be launched to the International Space Station for a month. And 8 significant R&D activities will be carried out by this astronaut, and 4 of them belong to the Hungarian space cluster. We are developing a special porous lightweight material using the regolith as a raw material on the Moon and the Mars. We have quite significant activities in the material aging and characterization of the aging. We will have an opportunity to put material samples of the outside of the International Space Station for a year, and we get back the samples for further investigation. From the human spaceflight, we are developing a fluorescent drug dosage detection. During the spaceflight, it is really important to measure and control the medicine effectiveness of the astronauts from their bloods. And from the space chemical point of view, there's a special development. It's a nanozyme nutrition for plants supporting long-term space mission. We develop a special equipment and a scientific experiment for that. One of our members, the Econ Engineering, I see that they will be presented in the today afternoon session. They are responsible for a kind of module of Axiom International Space Station. So they are supporting the Axiom. It's an American company from a structural design point of view. The Inner Studio, as one of our other members, they are really the leader in space chemistry activities. They are developing some equipment as well, but from scientific point of view, they are really a significant player in this community. The Sagax company, it's a small company, but they are highlighted by the aerospace and defense journey. Last month or something like that, they are working in the electronic and communication of different type of satellite equipment. And last but not least, the Aeroil company, they are working on quite complex plant design in different places of the Earth. And hopefully we can introduce them into the European spaceport in Kourou in French Guiana for some maintenance activities and establish new facilities in South America. So thank you for your attention. That was my presentation according to the Hungarian Space Cluster.
Thank you so much for your presentation, Tamás. The next speaker will be Martin Benck from the University of Miskolc, that will give us the presentation on the development concepts related to the space industry and related education at the University of Miskolc. So the floor is yours.
Thank you. I cannot share my screen. So Tamás, can you stop, or someone, the screen sharing?
I think there is
I think I stopped. What you see is shared by the screen.
Okay. Yeah, perfect. Thank you. Okay, just a minute, and now you should see the screen.
Yes.
Is it right? Okay, thank you.
We can see it. the floor is yours. Thank you.
Thank you for the introduction, ladies and gentlemen. My name is Marton Benke. I am an associate professor at the University of Miskolc, Hungary, at the Faculty of Material Science and Engineering. And in a couple of minutes, I would like to briefly introduce you those development concepts that are related to the space industry and the space engineering education at our university. To start with, I will show you a graph of the global space economy, which is the driving force of these actions. After that, I would like to talk a bit about Hungary's national space strategy, only the most relevant point from our perspective. After that, I will give you a brief introduction about our university and our space engineering related activities so far. And after that, I will talk about the development plan of the University of Miskolc, which involves the space engineering training and the project. So I'm sure that most of you are familiar with this graph. This shows the global space economy predicted to the near future, and you see that includes a lot of areas, including television, radio, mobile, satellite service, satellite observation services, and so on. And you see that we are talking about a huge business in terms of dollars. What is even more important is that the trend is increasing, and the increase is also increasing. So it's almost like an exponential increase in the near future. And this is, of course, the driving force of acts, such as the Hungary's space strategy, which was issued by our government recently. And in this document, 3 strategy goals are highlighted. The first one is to utilize possibilities within this sector that encourage innovation and growth of national economy. Second one is the strengthening the international role of Hungary, widening the connection network and creating the framework of coordination. And the third one is to develop the knowledge-based societal and economical conditions and the infrastructural background which is required for the prosperity of the space sector. So what actually this means that we need specialists, experts in the field of space engineering. We need the infrastructural background to train them and to handle projects, and of course we need the economical conditions for these operations. If we take a look at the short-term actions of this strategy, I collected only those which are relevant in points of our activities. The first one is the call-based funding of R&D groups and enterprises. So we expect upcoming projects within this field. The next one is promoting incubation activities of training and research institutions. After that, establishing internationally accredited test facilities, uniforming testing capabilities. I will talk about this a little bit later. Launching flagship projects such as the HUNAR program, which Tamás just talked about, the Hungarian researcher astronaut missions, own satellite program, etc. Introducing and sustaining middle and high-level education programs, which is, of course, will have a huge impact on our strategy plan as an educational institute. And, of course, developing user capabilities related to space technology. So you will see that we will have connections to almost all of these points, hopefully in the close near future. Okay, a couple of slides about our university. We are located in the northeastern part of Hungary. This is the entrance of our main building. The institute was established quite long ago in 1735. Now we have 8 faculties. 3 of them are engineering faculties, and all of them are going to be involved in the space strategy of the university. and roughly we have 10,000 students in total. So these are the official relevant data of our university. Some history or background about our space activities so far. These are the most important ones, the most highlighted ones. To start with, the Universal Multisom Crystallizer was established here together with the experts of EDMATIS. In brief, it's a solidification equipment in which the temperature gradient is moving instead of the specimen. And after a couple of developments, one of the latest ones was purchased by NASA, and it is in the Marshall Space Flight Center. By then, we have had quite many projects supported by ESA. Most of them are based on the directional solidification experiments in traveling or rotating magnetic fields. And we also have some PhD dissertations defended so far. These three are highly connected to space engineering. Most of them are deal with the rotating magnetic field and examine the magnetic hydrodynamic effect during solidification, or reducing the oriented Heusler single crystal specimen, or for instance study on the coating of an aluminum alloy. This is one of our latest laboratories, so I will not go through all of our capabilities. This is, let's say, the latest and greatest. It's called 3D Lab. The name means that we are able to characterize the material structure and some properties in 3 dimensions. In some cases also in 4 dimensions, which means that after the 3D characterization we do, let's say, another cycle loads, and after that we continue the characterization, and we do this in the cyclic manner. This also means that we have a 3D information about structure in situ in time, if you like. So this is called 4 dimension. About the equipment, we have an X-ray diffractometer, which uses the Rietveld analysis for phase analysis, also qualitative and quantitative phase analysis. It's equipped with a heating chamber, so we can do this analysis in situ during heating, so we can check the phase transformations. And it's also capable for the small angular X-ray scattering, which is dedicated for examination of coatings. The second equipment is a scanning electron microscope, which is equipped with a xenon plasma focused ion beam, with which we can do sectioning. And by sectioning one layer, doing the examinations, doing the sectioning again, and do this in a constitutive wave manner, we can reconstruct the structure in 3 dimensions using the backscatter or secondary electron imaging or whatever you need. It's also equipped with the electron backscatter diffraction, and of course for the composition we have the EDS detector. We have a dual tube computed tomography equipment, which is quite large in size, and it can take quite large specimens for examinations. So in some cases, when the component is below a certain limit, we can check the whole component without cutting a specimen out of it. And if we need smaller resolution, which means that higher detail of an image, or if we want to inspect smaller objects, then we can use the nanofocal X-ray tube, and then we can have the better resolution. And we also have an X-ray diffractometer, which is dedicated to measure residual stress. The specialty of this equipment is that it is attached on a robotic arm. The robotic arm can do rotations around 6 axes, which yields us a complete complex motion, if you like. So by doing so, it is possible to measure the residual stress without the need to cut small scale specimens out of the component or whatever it is. So for instance, if it's a huge axle, we do the examination without cutting the specimen, so destroying the component, and we do the examination and measure the real residual stress which is disturbed if you got a specimen out of it. So this is the latest lab of our infrastructure, and now let's go to the space engineering and space training program. We have a project started this year, and it lasts to 2026. You can see the title is Complex Institute Development Plan of the Renewing University of Miskolc. It's quite a large project, and one of the sub-programs is called Establishing Space Materials Science and Technology Research and Competence Center. So let's say one cluster focuses on space materials and space science, and within this sub-program we have 5 sub-programs. All of them are connected to the space material investigation. The first one is the space material research. After that we have the space material technology. Then we have focus on space material testing, the space material education, and the NESAT, which is a satellite program. And now I will introduce briefly these sub-programs. So the first one is Space Materials Research sub-program. The focus is to conduct researches on the behavior, transformations, and properties of materials which are brought to space by humans, and of course the emphasis on how these properties differ compared to Earth conditions. Now obviously the most relevant conditions are pressure, temperature, radiation, gravity, and buoyancy. This sub-program all of the program is being under construction, so it is just the idea, the definition of their goals. But we believe that most of these researches will be fundamental researches, so not applied researches, but fundamental ones. We expect to get high quality publications in high-ranked international journals in this field, and of course it will increase the international recognition of the University of Miskolc and Hungary. The second sub-program is the Space Materials Technology, in which the emphasis on the manufacturing methods of materials that we bring to space. We predict that the participations of national and international projects will be the largest in this sub-program. Of course, all of the sub-programs will operate in synergy, so it's not like only one sub-program will take part in projects, but this is the sub-program which is probably can generate memberships in projects. Of course, we also expect publications, maybe patents in this field, but we will see how it turns out. But this is the idea. The third one is the testing sub-program. Of course, we have some testing capabilities as a university, but for the special conditions and for the special requirements, we plan to establish a so-called space simulator in which some conditions can be simulated. Now, those conditions that we can simulate is under question, and of course, we are going to work together with Admatis and the HANSpace members how and what kind of simulator we can establish and operate. And once we achieve this, then we accept to run smaller projects in which we can fulfill industrial needs, mainly of the HANSpace members. And then we come to the education sub-program. We have quite a lot of levels of educations, starting with the MSc level. We call this space engineering as a specialization. I have to mention that this specialization has been initiated by the Budapest Technology University, but their focus is on the electrical aspect, and our focus is going to be, of course, on the material side. It will be held only in English, The duration is 4 semesters, and we plan the launch of this training next September. The subject list will be established together with Edmatis, and we are also plan to start this training as a dual program, which means that students will get the theoretical knowledge from the universities and the practical training from companies, and they also spend quite a notable time during semesters at companies. Of course, we plan to launch new PhD programs related to space engineering, and after the graduation, we plan to take part in postgraduate specialist trainings, which are dedicated for engineers, and this training will be held by consortium members, including universities, companies, so we are not going to lead this training, but we will participate in them, and also the specialized so-called spike trainings held by NASA and ESA and specialized companies, the training Tamás just mentioned in his presentation. And finally, we have the MESAT sub-program, which is about developing and creating a satellite by the University of Miskolc together with our students. We will determine the functions of the satellite, but obviously we will give them reasonable tasks, and then we follow its operation from the Earth. With this, it's not a secret that our goal is to draw attention to the space material trainings at our university, to make our trainings more attractive for the young researchers and the open-minded people, and of course provide possible and usable MSc and PhD thesis topics. So that was it. Thank you very much, and also some acknowledgement to the project which financed the presentation. Thank you very much once again.
Thank you so much for your presentation, Martin. The next speaker is right now with us physically, who is Javier Hidalgo Saez from GMV, a Spanish company that will talk us about the success cases aerospace, heavy industry, and manufacturing industries in Spain. So,
thank you, Eva. So thank you very much for inviting us, GMB, to this event. My name is Javier, as Eva was introducing me, and I'm a solution architect in the manufacturing sector of GMB. When we were preparing this presentation about success cases of aerospace and heavy industry sector in GMB, we identified a set of success cases we have in our company. But when I was coming to here today, I was thinking about that. I noticed that the very first success case of the company is the company itself. Let me talk just a bit about the GMB as a company. The company was created in 1984, and it was created by a group of people coming from a research and investigation group in the Technics University of Madrid. So the company itself is a success case in this area. They were developing solutions to be able to guide satellites for what will be later the European Space Agency, and they were able to follow this project, follow this commitment, and be able to develop a solution that was a success and was the real root of the company. Almost 40 years has passed since that year, since 1984, and the company has grown and diversified in different sectors. At this point, we are about 2,400 people working in the company. We have offices not only in Spain, but also in 10 different countries apart from Spain. And we have diversified in these sectors you can see in the screen: aeronautics, automotive, defense, industry, space. That was the root of the company. banking and finances, intelligent transport system, healthcare, public services, and industry. As said before, I'm working in this area, but more focusing what brings us here about the success cases itself. We were thinking about 5 different success cases in the company. I will not be talking about a lot of them because we are in a time restriction. So I will focus in the last one, the Agraria project. But let me talk a bit about different projects and what is something that is in the DNA of the company, that is the commitment with the innovation. At this point, GMB is not only a company that integrates solutions, but also a company that develops solutions. In this case, we had 2 different success cases. That is, the very first one is that the GMB is leading the largest ISA contract signed by a Spanish space industry for the maintenance and evolution of the Galileo ground control segment. We are talking about a project that is about 250 million euros in total. The second case is a contract we have with a German manufacturer of vehicles, and in this case is BMW, to provide them a solution to be able to use the GPS signal to be able to guide their autonomous and assisted driving vehicles. It is a solution that is developed by GMB. It's called Magic GNSS, and it is a solution that improves the accuracy of the GPS signal from 15 meters to 5 centimeters. Keep the name of this solution Magic GNSS because we'll be interested in later in the presentation. But we also working this year in 3 different projects coming from the mission initiative from the European Union. We had the project CUCO that is intended to investigate the use of quantum computing and their application to strategic industries, energy, finances, space, defense, and logistics. The project Tartaglia that is intended to create a federated network to accelerate the application of the artificial intelligence in healthcare systems. And the last is Agraria is intended to research in the application of the artificial intelligence in the value chain of the agricultural sector, in production, processing, and distribution. And I will focus in this last project. The Agraria project, as mentioned, has the main objective of the project is investigate the artificial intelligence as a backbone technology capable of providing a technological evolution of the value chain for the Spanish agricultural sector in 3 different areas: production, processing, and distribution. So we are not just focusing in a specific area, but in the comprehensive value chain from when the seed is planted in the fields up to when the product, the vegetables and other products arrive to the supermarket and the house of the final customer. In this sense, it is a project that is intended to provide this artificial intelligence applied to the needs and the problems that the different industries involved in the consortium have identified, but it's also about data. Data governance is the real underground factor that is moving all this development. As mentioned, the idea is the platform will allow the companies that have joined the consortium, at this point we are 24 companies, to solve representative problems identified in the sector. That could be when is the right moment to plant the seeds, when we should apply biopesticides, when the watering should be applied to the fields, but also about the processing itself, how we pack the component, how we transport that inside the production areas, and also about the distribution, how the products come from the from the producer to the final customer. We have identified different problems, different issues, different areas that could be improved, and the idea is apply this artificial intelligence to provide improvement in these areas and also facilitate the research in technologies that are interesting for these companies in the consortium to improve this production. But the idea is also learn from this experience, develop an interoperability module to facilitate the extrapolation and transfer the results and experience obtained in this area to be able to be applied in different use cases apart from the ones being developed in this project. It also takes in consideration the carbon footprint. The idea is to develop technologies in a way that are sustainable. So the idea is working algorithms, metrics, and means of production to reduce this carbon footprint. Also, it is an investigation and research project, so we are evolving, or the idea is being capable of evolving the different technologies involved in the project, making an evolution of the TRLs. As mentioned before, we have identified a set of use cases. We have a total of 14 use cases that will be used to validate the result obtained in the project. So I have already mentioned that we have a very big primary objective that is applied the artificial intelligence to the value chain. But this main project can be developed in two different ones. One of them is make a research in the complete value chain from the agricultural production through system managed by artificial intelligence, making intensive use of the advanced technologies with measurables and quantifiable objectives of drastic CO2 reduction, sustainability, energy efficiency, productivity, and competitiveness. The idea is improve the whole value chain. And also make a research in the application and use of different technologies and artificial intelligence in the most efficient and carbon neutral way, thinking about the future leadership of the sector by proposing use cases based on the generation of a new business model and a smart market demand. If we go to a concept map about the project, as mentioned before, the technological solution, the main one is the artificial intelligence, but the idea is make a test, make an evaluation about different ground technologies, about how they could be able to provide improvement in the value chain. And we have a number of technologies involved in this area because, as mentioned before, we go from the production, also the processing and the distribution. We talk here about the intelligent prediction system, robotics, machine learning, driver system, computer vision, virtual reality, and a set of technologies that are intended to be tested in this area. About the consortium itself, as mentioned before, we are at this point 24 companies and also partners working in this area. GMB acts as a coordinator and also a technological partner in the consortium. But we also have a set of technological partners that are some of the most important universities in Spain and also investigation groups, and also corporate partners, companies that are involved in the agriculture industries. We can talk in this area about companies like wine sellers, like Familia Torres or Amelger or similar, but also processing companies and logistics. And all these companies have different needs and have different interests in this consortium. That is the reason why we have 14 total use cases to investigate in this project. We have structured this project in different activities. The most important one, PT1 to PT3, are intended to work in the different sectors, in the different stages mentioned before, the production, the processing, and the distribution. But we also have a previous work package, the PT0, that is intended to develop a platform that is able to provide the different partners, the different companies interested in this solution, a comprehensive framework to be able to investigate technologies, to be able to provide data and to consolidate data, to be able to make usage of this experience and this information for their future work in production. So in total, we have these 4 different work packages in total, and the 14 use cases are distributed among these different work packages. Focusing in work package number 0 is the one about developing the platform. The idea, as mentioned before, is provide the different companies in the consortium with a technological platform that could make them make usage of these technologies to be able to develop the different use cases. The idea is providing a cloud platform with that it makes possible to make usage of these different technologies. And you can see here in the screen some of the core technologies that will be used in the platform: human-computer interaction, computer vision, machine learning, intelligent prediction system, that will be making usage of the data retrieved from the different companies. So the data, as mentioned before, is really important in this project. We will be also developing a platform to be able to work with federated data in two different aspects: governance of the data and interoperability of the data, because we have noticed that in most of the cases the issue with the information retrieved from these different consortium with different interests is that it's really difficult to make usage of this data to be able to extend the experience or be able to make usage of the data in different areas. So the idea is being able to procure, homogeneize, and explain the data and make then possible to be used in different experiences, so to be able to extend, learn, and be able to consume this data in different areas. Apart from these core technologies and federated platform data, we have a set of vertical technologies that will be used to make communication between the environment and the real world itself. So we'll be talking in this area about IoT and edge communication technologies like 5G, LoRaWAN, and also the other different technologies to be able to communicate between the environment and the ground, but also different technologies that will be used in the fields, like robotics, drones, cyber-physical systems, simulators, quantum computing, and other technologies that will be as capable of using this environment. But we have also highlighted the cybersecurity, because cybersecurity, that is a component that will be traversal to the whole platform, is a key point for us. GMB is a company that makes really a strong focus in the cybersecurity, because being comfortable, being confident, and being really willing to be used the platform is based in a strong cybersecurity and a strong protection of the data and the information managed by the different companies in the areas. This is the reason why this cybersecurity framework and technologies are highlighted in the slide. But also the idea is being able to extract information and apply that to the value chain and the production model in the field, in the three areas explained before, and extending that to different use cases, the 14 use cases mentioned before. Now, just to finish, I'm going to focus in two specific use cases that I wanted to bring to here. The first one that is really related with the aerospace and the production industry is the one about Kifnon. Kifnon is a company that is developing AGVs and robotic systems for indoor areas. They are developing robots and AGVs that are wire-guided and tape-guided. So this is a group of robots that work perfectly fine in indoor areas, in factories and so on, but are not really accurate to be able to work in the fields. So just imagine trying to put a wire through a plantation. It's not a real way to work in the real world. So the idea of this company is try to apply a solution based in the GPS. It is fine, but as mentioned before at the beginning of my presentation, the GPS has an accuracy of 15 meters that is not really useful to be able to work in a plantation with different lanes in the field. So just imagine trying to move, try to move in an area with a precision of 15 meters. It's not really suitable. So in this case, we will be trying to integrate our Magic GNSS solution, the one that was applied to the BMW vehicles, to be able to improve the accuracy to 5 centimeters. That is something that can be used in the real world. So the company won't be using anymore this wire guide to be able to work with the robots in the fields. The idea is working with this magic and also the 5G technologies. But this is only one part of the solution, because, okay, this is fine to be able to move the robot across the fields, but the robots should be able to work together and collaborate between them. And the idea is making use of onboard solutions to be able to work in a collaborative solution between the robots. And this is where put simply the NVIDIA solution. The NVIDIA solution is a product that makes suitable work in a ROS environment with heavy processing capabilities. The idea is that the robots can collaborate between themselves, sharing information, not only in the field, but also with the background platform solution. The idea is, in case one robot finds an obstacle in their way, a fence, flooding, and also people working in the area, should be able to share this information with the other robots, so the other can learn about the experience of the previous one and improve on demand the routing about the ground. The second one is for the LB Baggins company. This is a company based in Castilla y León that are working in solutions for bagging products in the production line. This company is working in robots, not only in robots but also in robotic arms that bag and pack products in the production line. They are at this point working with sacks of cement and also with pellets and products similar to that. And what they do is put in the production line any kind of these robots to be able to pack in groups the sacks of, as mentioned, whatever product to be able to be transported later by the logistic company. At this point, they are working with these robots that work with a predictable component that have to handle. For example, these sacks of cement or pellets have always the same shape, the same size, and the same weight. So it is really easy for them to pack them and pile them in a controlled way. But this solution is not really accurate for the agriculture environment, because if you think about cucumbers, oranges, and so on, every one of them have a different shape, have a different weight, and a different caliper, and they have to be classified in a different way. So in this case, the use case intends to evolve the product in two different ways. The first one is incorporate the computer vision to the platform to make the robot capable of distinguish between the shapes, the different shapes, the weights, and so on, to be able to identify the position of the product that have to be manipulated and pack them in their specific way. For example, if you think about the agricultural production, the fruits and also the vegetables are classified sometimes in terms of their size. So if it has a specific size, has to be packed in a different pallet according to the size and therefore the price. So it is not only about being able to identify the product, but also being able to distinguish and determine where this product has to be packed. And this is the second part of the use case, being able to collaborate in a multi-agent system and inter-robot collaboration about where the product has to be packed. And it involves not only picking that from the production line, but also putting that in the specific storage area that will be managed by a different robot. So the idea is being able to improve the production line in this non-deterministic way of collaborating. And this is everything from my side. We are working intensively in this project, and we will make it happen. Thank you very much for your time, and I hope this has been interesting for you.
Thank you so much. Our next speaker who will be talking about the success case in the Spain industry will be Daniel Fernandez, which is today with us. So, thank you so much.
¿Cómo lo están viendo ellos?
Igual que tú.
Igual que yo, entonces sí. Ponlo en duplicar igual que saben grande entero. Sí. Okay, thank you for letting me speaking in this event, and I will try to be short because I know there are still some speakers before lunch, so I'll try to give a short presentation at least. It's my intention. So I will try to present briefly our center and then going with the success cases of different issues related with manufacturing, materials, and aerospace. Well, first of all, just introducing briefly our center. We are an RTO, Idonial, the result of a merger of two technology centers. And what we foster is the technology transfer mainly in issues related with materials and manufacturing. These are shortly our figures. So we are based in the Asturias region, more or less 1 hour from here in León. And we are roughly 160 people. A fifth of them is a PhD. And we are mainly working in technological services, R&D projects, and with an annual turnover in the range of 9 to 10 million. These are briefly our main lines of activity. As you can see, there are engineering and simulation competencies. We have core competencies also in material selection and development, also in advanced manufacturing. In fact, most of the examples will be mainly related to that. And we have also two other areas or lines of specialization, one dealing with digital industry and the other with in-service behavior or advanced characterization. As a center focused in materials and manufacturing, we have a multi-sectorial approach, and that means that we have several examples. Some of them will be presented here, mainly the ones related with aerospace, but other mainly focus on the technology involved in each case, with a core issue in advanced manufacturing. This is the last, I think, slide for the introduction of the center, just to highlight the main activities that we are performing as a technology center. As I mentioned before, the engineering and simulation has core competencies in different finite element method or analysis, division for mechatronics for the first prototypes and series, knowledge in topology optimization and in process simulation. Regarding material development, we have wide knowledge in steel and metallic alloys. In fact, we have a small steel making factory, so we can create new series of steel grades and other metallic alloys up to 150 kilos, and then process them. And well, there are other activities related with coatings, etc. The advanced manufacturing area is mainly dealing with the technologies included in 3D printing, from laser-based systems to other, let's say, in higher scale, like wire arc additive manufacturing that I will explain later on. We have experience also with other materials like ceramics, and I will also explain one of the case studies in the presentation. In relation with digital industry, I will briefly show some examples in relation with sensors, and finally in issues related with quality and in service behavior. We perform different mechanical tests. We have also wide knowledge in different failure analysis, and different labs mainly dealing with tribology, wear, fatigue, fracture mechanics, or fitness for service approaches. Then I will go more into detail with the different case studies that I will present today. First of all, is the one really aligned with the topic of the event. I mean, from the aerospace sector, we had this experience some years ago, where we performed a model and design, and also the manufacturing by 3D printing of this titanium alloy, and the post-processing activities that led to I think a really valuable result in terms of reducing the time for manufacturing up to 25%, and also reducing the weight for this light or for this aerospace application. It was a hinge that was present in this project, and it was also reduced up to 28%. We have other examples of, let's say, topology optimization and the subsequent activities in relation with manufacturing. That means additive manufacturing and the machining in the post-processing part, and it also led to a reduction up to 39% of the weight of this part for the railway sector. Another example, more related to materials or to steel in this case, is the design and development of experimental alloys. As I mentioned before, we have a small steel making plant that give us also the opportunity to develop materials also for additive manufacturing, issues related with atomization, etc., and different metallic alloys at the level of kilos, as I mentioned. That involves steel, but also other lighter alloys. Aligned with that, we have the success case for the, let's say, nuclear fusion activities with our own steel grade that we were named as Turfer, roughly 10 years or more ago. And also aligned with materials, there are other case studies that we are proud of them that are mainly dealing with vacuum-based coating that sometimes are applicable to the fields that are present today in the event. In the next slides, I will present other activities, mainly dealing, as I mentioned, with additive manufacturing. This is an example for the company Ramen, mainly focusing this component, this instrumentation comp, that is using a material good for high temperature application, and where we also apply different post-processing with the polishing of this piece. The good news is also that we can create this in just one piece. So sometimes it's also a prerequisite from the client. Another example of a project related with the European Space Agency was the development of this communication waveguide, also through the process including the optimization of the design, the manufacturing by 3D printing, and the post-processing of the inner surfaces with a kind of liquids to achieve the requirement in this case. In relation with this, another case study is another technique called WAM, wire arc additive manufacturing, that, let's say, is a mix of the 3D printing itself and welding capabilities. and we apply these means for the development of a piece based on titanium alloy for a vehicle. Apart from that, I'm mainly related with this welding department. We are also working with ITER, the main initiative in relation with fusion, and this is an image from their website highlighting the activities developed by Doniel in the frame of developing, in this case, a mock-up of one of the pieces to be manufactured and pre-present at ITER, and this is one of the references that are present in these, let's say, big science facilities, where we are mainly working for engineering and welding, and also for the inspection plans activities. In relation with the engineering and simulation activities and related with welding, we developed a tool in the frame of a European project some years ago. Now is an activity that is being performed running under the ANSYS software, and allow us to define the best welding strategy, and also in the other issues, for example, for the clamping of the different sets to be done. This started as a project, but nowadays something that is used by different companies, and is something with really good results, also validated at our lab. This is another example, mainly dealing with the defense sector. This is a contract we had with the European Defense Agency some years ago, where we developed this mobile plant or container to be used at any isolated area, and giving us the possibility to obtain different spare parts or prototypes that are needed. It has been in use for different armies in Europe, and well, the feedback from the defense sector is quite good. We are also dealing with other technologies like micromachining that give us also some interaction with companies in the definition of the parameters of the different equipment involved in these manufacturing activities, and we can work in the range of tolerances and accuracy that is presented in this slide. It is something that has been, or it's let's say a kind of means that are usually well received from the manufacturing companies in just to save time when they apply the knowledge in their manufacturing processes, reducing the amount of errors. Another issue related with additive manufacturing and advanced materials is the manufacturing, the 3D printing itself of ceramic components. That is also applicable for the first part of the, let's say, the optimization design, and then the manufacturing itself. We have some examples in different sectors, and also in issues related, for example, with antenna guides or aircraft instrumentation, with some companies that are mentioned there. Another example of this, let's say, mix of materials, knowledge, and manufacturing is in relation with the defense, where we have a project funded by the Spanish government from the Spanish ministry, where we are developing euxetic materials for, let's say, protection, or a lighter protection. So it's something that is being developed with a company also based in Castilla y León, Cituri, who is partnering in this project, and with another technological center known as Sidotech. Also, ArcelorMittal is giving us support in this field. Other examples, for example, with another company here in Spain, is for the development of these additive manufacturing technologies for heat pipes that are critical for heat energy applications, that at the same time are applicable for sectors including aerospace. And in relation with collaborative projects in the field of aerospace industry, there is a project that finished 3 or 4 years ago. It was an Horizon 2020 project where we were partners with the other partners that are present in the right part of the presentation. And we developed a mobile robot with, let's say, smart applications for the sealant and also for inspection. So there were also some issues related with robotics and vision. Another project in Horizon 2020 was the symbiotic, where we dig a little bit more in human-robot interaction in issues related again with the aerospace sector, with different industrial partners involved there, and it also had some good feedback, and also there are in YouTube some info available. And for a matter of time, I won't be able to give more news on that. In relation with these digital industry activities, we are also working in the digital twin concept and simulation. In fact, we have a national project called Mirajet for this strategic positioning together with other technology centers in virtual models and digital twins. And it has been also validated at different workshops and industry in order to highlight the potential for avoiding inefficiencies and bottlenecks during production. In relation with sensors and augmented and virtual reality, we have also a lab, and the means for developing and integrating commercial or ad hoc developed sensors. And in this sense, it's a overall integration of what industry demands. So in this sense, we have applied sensors for the steel making and for renewables and other sectors. I'm coming more or less to the last part of the presentation, more or less on time, I think. So I will just highlight the part related with quality control that is also present at Idonial, mainly through our metrology department, also with a specific view in process control and with mechanical tests, where we have several labs where we can perform not just the classical mechanical tests or chemical tests, but also other, let's say, more complex, like the fatigue characterization of materials and components. So we count on a test bench where we can apply this advanced testing on components, on welded joints, or in pieces up to 4 meters of dimension. And there are some experience in the aeronautical sector that are, well, subject to a confidentiality agreement, so I won't go more into details. And that was all. I hope it is of your interest, and I open to interact with you later on. And thank you very much.
Thank you so much. And now we have the last case of the industries coming from Spain, the last success Spanish case, with who is Javier Rodríguez Vaquero from IMAPA. He is the head of Quality and Health and Safety Department. The floor is yours.
Good morning, my name is Javier Rodríguez and I work in Grupo IMAPA. It's a pleasure for us to participate in this workshop. I will try to be brief in order not to delay more the planned schedule. Maybe I can jump some slides. The success case is the company, how a small workshop become a tier 1 for a lot of companies. Grupo IMAPA is a company focused in the industry. Our aim is to help other companies to improve. Something about us. We are located in Villamuriel de Cerrato, a village near to Palencia, the capital of the province, 250 kilometers to the north from Madrid. Our sales are around 50 million euros. And we were 450 people, more or less. Grupo IMAPA started in 1967. Pedro Sagredo Sainz de Aja set up a small workshop in Palencia, and the company grew up. And in 1990, we took the important decision, creating our own mechanical and electrical engineering department. We started to work in different sectors, automotive, railway, aeronautic, mainly doing tooling and installation. But in 2002, we started to manufacture metallic parts for aircraft. At that moment, it's created IMAPA Aeronautica, a specialized division to supply this kind of items. In 2014, we set up the first surface and painting treatment line for metallic parts. And nowadays, we are in Industry 4.0. We are incorporating new technologies in our machines and in our manufacturing processes. Our philosophy in 4 words will be client, people, quality, and I+D, 4 or 5. Our client is the most important for us. The strong customer focus has been an essential part of Grupo IMAPA's success. The quality commitment at Grupo IMAPA is the pillar of our work philosophy, which allow us to guarantee that our products and service meet our customer expectation. People are the most valuable asset that Grupo IMAPA has. We can take of them, and we develop family conciliation and quality policies. I+D, we provide integral solution incorporating the most advanced technologies at the industrial automation service, at Industria 4.0. We contribute to the improvement of manufacturing system by providing creativity and innovation to all our projects. What does Grupo IMAPA do? We can summarize in 3 groups. The first is Turkey project. We do design, manufacture, assembly, and setup. Some example of this kind of supplies: automation installation, automatic machine, tooling for carbon fiber manufacturing. weapon handling and display component from the same submarine, in this case from Babcock. Weapon embarkation system from the submarine Django boat. Transact and the case from the submarine S-80. The mast from periscope from the submarine of the class Virginia. This is the main body of the Meteor missile. In this case, the customer is Indra. The manufacture and setup of external aluminum cases for the SCOI vehicle. The customer is General Dynamics. In energy, manufacture components from the ITER Tomahawk. In this case, we work with ENSA. In the automotive sector, we were designing, manufacturing, and setting up welding installation. In this case, these are from Renault. This installation are from Michelin. We do the design, the manufacture, and the setting up. This is forming dies. We work with a lot of clients. The most important are Gestam and Alcalá. And regular samples, for example, milling train wheels and bogies, and welding and milling different components of the train. And this is all. I think I am on time, more or less. You can visit our web or follow us in our LinkedIn. If you have any doubt, you can contact me now in the lunch or something like that. This is all.
Thank you so much. Now it's time to know more about the success cases and stories from the Miskolc region. Our first intervention will come today with Akos Horvath, which is the CFD team leader of Econ Engineering. So please, Akos, you can start.
Okay, hello. Good afternoon. First of all, thank you very much for the opportunity to let us introduce some, or actually in this case, a success story from Econ Engineering, which is titled Icing Wind Tunnel Design and Construction. Very nice project we have performed last year and finished this year. And just a moment, maybe I switch to presentation mode. I hope you see my screen.
Yes, we are seeing it. Perfect.
Okay. So first, a few slides about Econ Engineering. We are a cooperative engineering partner engaged in consultation and CAE services and special purpose machine design, so automation. And throughout high added value simulation technologies, we believe that we can offer faster and more reliable product development to our customers. Econ Engineering is a fully Hungarian company owned by 3 engineers actively working in the company, and they founded it in 2002, and at the moment we are more than 80 employees, and the total turnover last year was about a bit more than 7 million euro. We are certified ISO 9001, 27001, and Type 6 level 3 certified for mostly for German automotive industry. It's coming from there, and certified for the GE IT security as well. One of our main department and their main focus is software distribution of ANSYS and Modex 3D, and since a while also particle works and SPH method. Regarding the CAE, we do structural mechanics and dynamic simulations with several software tools, including ANSYS, not exclusively, and also for sure CFD simulations, electromagnetic simulations, which is increasing a lot, the demand increasing a lot in the last few years. Geometry optimizations, parameter optimizations, so all these cutting-edge technologies, and we are very proud of that. Our composite material know-how is probably or is very high. In the recent years, we have started to deal also with artificial intelligence and machine learning, how to implement them in the simulation technology to bring out more from this technology. And as I already mentioned, a department at Econ Engineering is designing, constructing, and delivering special purpose machines, mostly for automotive industry, and mostly for the Hungarian market, but not exclusively. We already had some projects to Poland and Germany. Here is a short overview of our history. So as I mentioned, company has been founded in 2002, and yeah, probably it's not most up to date, but at the moment we are over 80 engineers. And what I wanted to show you today, as I already mentioned, a very nice project from last year to give you some idea how we have constructed this wind tunnel for a Hungarian university, which specialty is that it can be cooled down to -20 degrees Celsius, and there is a water injection system. The purpose of the wind tunnel, of this wind tunnel, is to investigate icing conditions at relatively low Reynolds numbers, which exist around high voltage cables and windmills. So around the blades of these wind farms. It's, as you can see in the picture, it's a closed loop with an axial fan with a contraction ratio of around 5, and has a test chamber of 500 millimeters times 500 millimeter with a length of 1 meter, and the maximum speed that we could reach is 38 meters per second with a rather low turbulence intensity. As I mentioned, the border spray bar system has been installed, or can be installed actually, because it's a removable spray bar. So it's up to the research or up to the specific task whether they implement it or not. Here you can see the layout that actually I designed based on a lot of research and different CFD studies. So the flow goes around in counterclockwise direction. It has an axial fan. It's a commercial product actually. It has been selected based on the aerodynamic analysis that we've performed. There is a fan tube heat exchanger which ensures the cooling capacity of around 24 kilowatt. And here, just before the construction, you can see the so-called settling chamber with different screens and honeycombs to ensure that relatively rather low turbulence intensity in the test chamber. The corners are bladed to also, let's say, decrease the pressure drop, and more importantly to homogenize the flow, particularly in the fourth corner, and to get a more homogeneous and low turbulence intensity field at the entrance of the test chamber. As I mentioned, the design has been investigated in a parametric CFD model to find the optimum for the given task. We analyzed more than 50 variants, and we supported the fan selection to find optimal size, performance, and position for the fan. The contraction shape was also scope of the CFD studies to ensure flow homogeneity and turbulence intensity at the entrance of the measurement chamber. And also we have run some studies on the water injection system to analyze flow paths of different particle sizes or droplet sizes in function of airspeed and other parameters. At the end of the project, or close to the end of the project, we had to also quantify the turbulence intensity and the flow homogeneity that, so how the wind tunnel performs. And here you can see a picture from the measurement that we performed with this constant temperature anemometry, also known as CTA, and some results that you can see here. Turbulence in the bottom diagram shows turbulence intensity in function of airspeed, and the right diagram shows flow homogeneity, or actually deviation from the air velocity measured at the center in percentile scale in function of airspeed. The construction itself, it's a segmented wind tunnel, so one can deassemble it if they wish so. The most important reason was that, for sure, to be able to deliver it to the site, but more importantly, that as you will see it on some slides later, that this wind tunnel has been installed in the cellar, where there were some, let's say, relatively or rather low restrictions. How can we put it in there in that room? It's a stainless steel design, a screw design, but without bolt heads at the inner sides of the channel. Could be, the reason was that to really ensure low turbulence intensity. And there are many eye holes at upstream and downstream corners, upstream and downstream the fan, so one can check what's happening inside if you wish so. The design itself is a thermal bridge-free design. We use a material called Purinite, which has a really low heat conductivity, but rather good mechanical properties. And over at the external side of the wind tunnel, there's around 8 centimeters of foam insulation. The settling chamber, upstream the contraction, contains a honeycomb which is fixed, but upstream the honeycomb and downstream the honeycomb there are slots for screens, and this makes really useful for the university, because they can also analyze the effect of different screens and different combination of screens on turbulence intensity if they wish so later on. So one can remove or relocate the screens in 5 minutes probably. So it's, I think it's a rather innovative design because it opens possibility to investigate effect of screens on the flow field as well. Here is a slide about the spray bar system. So it's a removable spray bar. If I go back one slide, just a moment. So the spray bar is even more downstream of the screens. Actually here in this very right end of this picture, behind this door. So it's in a bracket which can be also removed. And as you can see, it's an aerodynamic external shape. It has an aerodynamic external shape in which there are 3 air nozzles, air-assisted nozzles, with water lines, air lines, and electrical cables. So one can adjust the properties in a very accurate manner. Just one slide about the heat exchanger, which is a rather big part of the project, or has been a rather big part of the project. Since its electrical power demands, it's around 46 kilowatt, And yeah, the major part of that is actually outdoor installed, just in front of the building. Some pictures which we take during the construction. So here on the left, you can see the aggregate with this electrical power of 46 kilowatt. And it's a two-loop cooling system with a water glycol reservoir of 2 cubic meters with a heat exchanger inside. So this makes possible or feasible good controllability through the three-way valve and the secondary pump. So we can play around with these two parameters, at which speed we run the secondary pump and how much we open the valve. And the fin tube heat exchanger, which is thematically shown here as the one which is inbuilt into the wind tunnel. So the right and here of this schematic picture is the wind tunnel. And here are a few pictures from the construction. At the bottom left, you see the final installation room. It was, yeah, not too much larger than the wind tunnel itself. For sure, it was adjusted to that, so one can actually walk around the wind tunnel, but there's no much too much space left behind. And yeah, just one picture from the very first results. It's not, I wouldn't say it's a scientific measurement. We just tested it, how it works, whether we can really cool down to minus 20 degrees Celsius. The water injection works, and in principle, the full design could fulfill the specifications. And yeah, now it's it has been delivered finally to the customer, to the university, and then they can start scientific measurement of that. Thank you very much for your attention. In case you're interested in econ engineering, you can contact me over my email address, or you can contact the company itself through our address. Thank you very much.
Thank you so much, Akos. We have now David Palmer with us. David, can you hear us?
Yes, of course.
Okay.
Do you hear me?
Yes, no problem.
Okay.
So the floor is yours. If it's possible that you shorten a bit, your presentation will be perfect.
Yes, of course.
Thank you so much.
So do you see the presentation?
Yes, but not in full screen mode yet.
Now it's okay?
Not yet?
Not
it is
yet.
loaded, maybe.
Just a moment.
Okay.
Now?
Now it's okay. Perfect. Thank you so much.
Perfect. Thank you. So, dear audience, thank you very much for the invitation for this event. And let me introduce us. We are a Hungarian private company which was founded in 1990. Basically we are engineering services and around the establishment of the company focused on the nuclear industry, but after time there are two other divisions are opened. One was the additive manufacturing, and the second one is the medical device technologies. Just a short timeline. Since 2012 we are in the additive manufacturing services, and we have two partners in Hungary from Austria. One is a metal powder manufacturer, and the other is a software development company, and we are the Hungarian partner of them. And our services to the Hungarian customers is this kind of divisions. So research and development, additive manufacturing, consulting, material testing, metal powder and software. Basically, we want to support the companies in the Hungarian market. They want to start in the additive manufacturing field and they have no idea how to start it, but it's additive manufacturing. We are not to the customer side, but in the industrial side. So we do not support desktop printers, but mostly metal additive manufacturing systems. I like this slide because it's it take a look about that how additive manufacturing today are additive manufacturing technologies. That means that the first additive manufacturing thinking was in the quite past time, but today we are now on standard serial production with AM. Due to this, it's important to know all the standards, all the design rules, or everything about AM, but the customers mostly do not have the knowledge to go in deep inside in this direction and produce very high end use parts. So the Hungarian market or industries and users look like so. In Hungary, there are approximately 50 machines, and as you see, the two big part is the medical sector, the other is the industry. But we have in Hungary also 14 approximately 14 machine. They are just to have, so they are not in daily use. They don't know what to do with the machines, but there are the machines. So, but also universities have metal printers, and they try to use in everyday science and development or research, and I think it's very good point in Hungary. The most common used metal in Hungary is, as you can see, the aluminium or steels. As the slide showed before, that we have a big medical sector. Due to this, the titanium and cobalt is a very common material, but also there are companies they try to use copper and also special steels. Not just these are on the slides. As we, the Hungarian partner of the metal powder producer, we can offer to the Hungarian customers very special high performance materials, and also we can support them with parameters and also with post-processing solutions like heat treatment or also surface modifications. So that there is a possibility if anyone wants to use here in Hungary special material for a special project. There is a lot of material possibility. So why our activity is important in Hungary? I think this circle shows that the total year production process is quite bigger than anyone if have a machine. So if anyone have a machine, it's just a point in the whole process flow, and they need the independent support to be success in a short time. So the IM efficiency, as you see, not just time, cost, and quality, but how to reach with that. There are 3 options: to replicate, adapt, and optimize parts. And we have to the customers to find the best design or the best producing rules to the project according time, cost, and quality. So there are part properties. It's very difficult. So not just material testing or microstructures, material properties, but also can have special structures, defects which can be detected, and also the surface properties, if surface properties is important or not. So a lot of customers in Hungary, they want to produce parts, but they don't care about the material properties and also the defects or some other lack of fusion or other defect types which highly influence the lifetime of the part. So that we can help the customers to give a point of view how to solve these kind of problems. Also, the data preparation in Hungary is lectured by the OEMs who give a software to the machine, but they cannot ask as short time the OEMs if the customer have a problem. So with our software solution, we can be a good point at the customers and can help in a short time that they find the best orientation or supporting or support structure on everything else. As I mentioned before, so part and material qualification is important, and in Hungary there is a gap, and what you need to do this is to know the standards, also the non-standards testing methods, or can you produce samples, not just standards but non-standard samples, also powder testing and mechanical analysis as well. So we try to cover all of the AM processes with metal-based AM processes and help the customers go deeply inside of the geometry, design, material, data preparation, quality control, 3D printing processes, and cross processes. And some case study that I can show you, that was with our partner company in a motorsport. So the goal was that some structural components to reduction weight, increase the stiffness, and shorten the production time. So to this, use the special topology optimization software, and also optimize the 3D printing orientation and support with the minimal post-processing work. And at the end of the project, we get a special part, and you can see the summarized result that the general material, how the weight, the deflection, the maximum load was, and with the special strength aluminium material, much better. So we reached weight reduction, increased stiffness, and also the production of these parts are in 2 days. With the post-processing in 3 days, everyone can get this kind of solution. So the take-home messages was that PAB is an independent AM engineering office in Hungary. We have sales activities with our Austrian partners, and in metal powders and data preparation software. And we can help to our customers in the following points. And if you have further questions, then please do not hesitate and contact with us. So thank you very much for your attention.
Thank you so much for intervention, David. And now we enter into the SMEs elevator pitches time. We have first the Hungarian SMEs, and the first turn will be Tamás Barsi, representing Admatis. So, Tamás, the floor is yours.
Thank you very much. Hello, everybody again. I got a request that try to be as short as possible. Like to
thank you so much. Yep.
With the need, I have only 3 slides. Now I'm presenting something about my company. The name is Admatis. It's a shortening of the Advanced Materials in Space. This company is a Hungarian, and it is identified as one of the prime company in Hungary. Here you can see some buzzword, and the largest letters shows that we are really focusing on the space. It means that we have no other activities than the space. We have some R&D activities and flight hardware and industrial project as well. In general, the company was founded in 2000, so 22 years ago, and the owners are Hungarian private persons. It's an SME located in Miskolc, and we are focusing on the space, and within the space, the thermal and structural engineering, supported highly with material engineering, material science, and material technology development. We would prefer the build to spec the type of activity. It means that our most preferable cooperation way with the customers, that if they have a problem to be solved by somebody, we are already here to offer different kind of solutions, some trade-offs, and at the end of the day, put something on the table, hardware that can be used in a satellite. Here you can some information about the customers. We have really good cooperation with European large space integrators, Thales Alenia Space and Airbus, and of course the ESA. But we have connected and we have connection with the NASA, and we have cooperation in Switzerland with the University of Bern and the RUA. So what we have, we can offer satellite technologies for flight hardware and for ground segment equipment part of it. But both of them, we are focusing on the thermal and structural one. On the bottom line, you can see some references. The Sentinel-2 satellite family was developed in the last decade. Thousands of hardwares per satellite to the payload equipment have been developed, designed by us, and delivered directly to Airbus. The first 2 satellites are on orbit. The third and the fourth one is in integration and verification phase to be launched in the coming years. The JUICE mission, it's a Jupiter science mission. The MLI have been developed. The CALOPS, the radiator, the thermal control system, have been designed and delivered by us, and the focus experiment was executed on the board of the International Space Station. It was a forming scientific experiment. And what are the ongoing activities at the company? Here you can see one of the flight activities. The Ariel mission is a medium-class scientific mission organized by the European Space Agency. We are responsible for flight radiators and MGSEs. The Comet Interceptor, one of the scientific instruments, the camera, fully thermal control system, under responsibility. The CO2M satellite and the SHIME satellites are part of the ESA Copernicus program. In the SHIME mission, we were responsible, we are in a negotiation with the Italian Slovenian space. All of the MLIs, the multi-day arrays later, will be developed by us in the next years, while in the CO2M mission, the active and passive thermal control. In the Mars program, a space dosimeter telescope are under development. It is just started a few weeks ago, but 2.5 years later we need to deliver the fully qualified flight hardware directly to Airbus, and it is also supervised by the European Space Agency. The MSN is a marker supporting navigation activity. It's a kind of aging project. We are developing a Tier 7 grade markers that are age resistant, so it means that most of the properties, the beginning of life and end of life values are close to each other, so there's no significant degradation during more than 10 years in low Earth orbit space condition. The positive and the age projects are part of the Hungarian astronaut program. The positive is a material technology development to support the habitation of the moon and later the Martian habitat. We want to use the regolith, the powder that can be obtained on the surface of the moon, as a raw material, and use this type of material as a kind of structural one to develop a highly porosity structural material. And the age project is a material and aging. It's a characterization of different type of material samples after 1 year low Earth orbit space exposure, in direct exposure and under the condition, and we will try to somehow determine or validate the engineering method of the testing of the materials from radiation point of view. So this is what we are. I hope that I can be short, as you like. If you have any question, I'm here. Try to react. Thank you for your attention.
Thank you so much for your briefness and for your presentation. And now the next speaker is Charles Pastor, which is representing the next company, which is Premier. So, Scholt, the floor is yours.
Okay, thank you very much. Can you see my presentation?
Yes.
Okay, thank you very much. My name is Zsolt Pásztor, and I am the Managing Director of Premier. Thank you for the opportunity to give a brief overview on our activity. Our mission is improving quality of life by providing innovative and efficient solutions. Our activity focuses on 3 topics or 3 areas. On one hand, the production of innovative person-specific medical devices, professional application of metal 3D printing, and finally, the carrying out research and development activities related to the previous topics. We are a member in several organizations in Hungary, Industry 4.0 National Technology Platform, the Medicluster, the Hungarian Additive Technology Association, and also a community, international community, 3D Hills, that deals with 3D printing in the health sector. So in our activity, we primarily focus on 2 sectors, on the dental and medical sector, and related to research and development to the aerospace sector as well. Our research and development activity focuses on the following topics. improvement of metal 3D printing process. We use the so-called laser power bed fusion technology. We use primary titanium as a raw material. Naturally, we can use other metals as well, but to these two sectors, these are the metals that fits better. We also carry out thermal treatment of the printed parts, because this is very important for us. And just a few success stories or pictures of success stories related to this present workshop. In a project related to the aerospace sector, we could substantially increase or reduce the porosity of the as-printed parts, and also subsequently that of the heat-treated parts. These are the results can be seen on these two slides. Just for your information, the porosity in this case is below 0.005%, which is very low for an as-printed part. Generally, a porosity of 0.5% is already considered appropriate or acceptable in additive manufacturing, and for the heat-treated part, practically in the heat-treated part, no defects were detected. We also put a high emphasis on the surface treatment of the printed parts. In case of dental and medical implants, this is particularly important. So on the right side of the slide, you can see a picture on the surface of an implant treated by us. We also carry out simulations. The simulations covers both our products and our processes. Concerning the production and our products, as I mentioned, we focus on the production of custom-made medical devices, partly or mainly for the dental sector, the general or the traditional products like crowns, bridges, sheets. Our intention is, and the development goes in the direction of production of medical implants, dental implants like superior style implants, but also so-called maxillofacial implants. You can see a few pictures of the parts we have already, or implants we have already produced. At present, we concentrate on the human sector or the human part, but the veterinary production of veterinary implants is also in the pipeline. And as a hobby and test labor, we also print souvenirs. You can see a few examples on the right side. All of them were produced by us. And this is a very good laboratory for us to test the limits of the different processes, like how complex parts can be printed, and also how the surface of the parts can be treated, especially for such complex objects. Concerning international collaborations, we can say we're quite active in research and development projects. We took part in Eureka project, in two H2020 projects. Those projects are ongoing, and we expect to start one Eurostars project in the near future. In addition to this project, we have already submitted several applications for recent calls. And we already have some collaboration or contact with Spanish companies. One of them is Xcalet. They develop the software and the methodology for the production of ortheses. And we are their partner in Hungary, and we also intend to produce these custom-made ortheses for the patients. And also, we were in contact with GPR Innova. We purchased a polishing and electro-polishing machine from them that works quite well, and we are satisfied with that. And we are open for further challenges and further collaborations with other Spanish companies and organizations. Thank you very much. Hello?
Thank you so much, Scholt.
You are welcome. Thank you.
And now we enter in the latest part of the workshop of today. We have the Spanish SME representation with elevator pitches that we are going to do as a video retransmission. Se va a escuchar por aquí.
¿Por ahí?
Good afternoon to all. My name is Pavel. Thanks to all for this opportunity to speak about our company. Our company is Setlands. Setlands is a recently created company focused mainly on the aerospace sector. It's made up of a young multidisciplinary team from the technical and the new technologies people. The team experience goes beyond 20 years within the aerospace and the engineering sector. All this coupled with changing market trends, we are always adapting to customers' needs. In the past, the big aircraft brands dominated, managed, and manufactured most of the processes in the integral way. Only small engineering companies, as we are, acted with representatives of a few brands providing local and technical supports. Little by little, it was changing into a model in which the big aircraft brands subcontracted each process little by little. Likewise, a great diversity of new component and tool manufacturers appeared, which allowed us to establish ourselves as tool and equipment manufacturers. For this reason, engineering companies like us have been adapted to cover our needs, increasing in importance our own product and service, such as just-in-time logistics. Currently, most aircraft brands only manage final processes and outsource most processes and production. So, companies like us have adapted to cover all these needs in an integral way. Our greatest ability is the transmission of knowledge and contribution of experience in the aerospace sector within the and military branches. In the production area, manufacture of composite material and machining of composite, metallic and superalloy materials, assembly lines for aerospace structures, helicopters and airplanes, motor power plants and electrical installation. In the maintenance area, we are working with large and prestigious airlines, as well as all types of aircraft in the rescue sector, amphibious aircraft, rescue and security helicopters. We also work with preservation and scraping companies very famous in Spain and France. To meet all this, we are always meeting with customers. We train them, collaborate to define production processes or production chain, and finally, we define the supply chain. A very important point and highly valued by our customers, both for the airwork material and for tool and tooling use, as well as the technologies to avoid the food problem. We work hand in hand with the main OEM manufacturers approved by the main aircraft and helicopter brands, and the tier chain approved process of contractor, offering education and training and after-sales support for any manufacturing or maintenance problem. For any specific need that does not exist in the market, we design and manufacture all types of solutions, tools and tooling. We also collaborate in any innovative project related to aerospace and space. As engineering company, we carry out energy, electrical and structural studies, and if the customer needs the integral solution or execution of the project, we also execute it. We are currently immersed in the following: development of an aerotaxi manufacturing project, as you can see in the image. Develop of a comprehensive project for the manufacture and supply of tools that is unique in the market. I hope I have been able to resume all our work. Thank you for your attention. Bye.
And we have now the latest video of the Spanish SMEs, which is a representation from Carlos Bernabeu, who is the director of the entity. And we will see.
Hi, I'm Carlos Bernabeu. I'm the CEO and founder of Arboria Intelbirth. Arboria is a small company, a private company, from Science Park from University of Salamanca. We are a company integrated in the structures of the Science Park from near 12 years ago, and we work together, a team of different technicians, creating and design drones, robots and software for the analysis, for the inspection of the big structures of the industry of the energy, especially the renewables energy. We have been pioneer in the use of drones for the inspection of the structures in Europe. We have been pioneer also in the training of pilots. From 12 years ago, we beginning to do it, and also for a kind of inspection we call deferred inspection, created digital twins of the structures for make the inspection out of the land. And with this kind of service, we work international. We give international service for the bigger players in the world of the energy. Now I will show you a small video about our company for understand what is kind of research and investigation and services and drones we create, because we make every piece of our drones here in Salamanca. These are our facilities in the Science Park of the University of Salamanca. We began 12 years ago to design and build different kinds of multi-rotors with the focus of the civil use, especially the inspection of blades, of wind turbine blades. In this way, we have been design of every piece using carbon fiber and different polymers, and our drones, our multi-rotors are very hard creatures. We have any of them flying in a hard condition, in a hard environment, from maybe 8 years ago, making inspection of blades in a wind turbines under a very strong winds. We create technology for working very hard conditions, and we use for inspection also not only wind turbines but also the inspection of power lines or the other bigger structures in the industry of the energy. From a long time ago, we collaborate very close with the Spanish Army, because we have here, near of our facilities in Salamanca, the School of Pilots, also of the U.S. pilot from the Army of Spain, and we work very close with them in collaboration maybe 10 years, more than 10 years ago. And more than 10 years ago, we beginning to train pilots. We have been pioneering this kind of use. And we work very close also with different companies of the world of the renewable energies, especially with Iberdrola. We have been Iberdrola like a stakeholder in the company during 8 years, and now in a venture capital fund, but now we work like a partner in the development of technology, and they are any of our more important customers. Our company developed his own drones, as I told, with polymers and composites, and also titanium alloys, because we designed these drones for fly not only in inspection of this structure, but also to focus it in the sea, in the operation in the sea. Okay, this is our interval. Thank you very much for inviting me to this symposium, and I have been pleased to.
Okay, thank you very much. So, it's time to close our workshop. Thanks a lot for all the people that has been present today. Thanks a lot to all the speakers online. Thank you very much for following us. Now it's time to enjoy. We are going to have a very nice lunch in an old fashioned and ancient emblematic building of León, who is, it was an old convent in the past, and I think it's some place which the national is also part of the national network of paradores, no? What our cultural heritage buildings. And well, thanks to the people online. Looking forward to have you next time here in León in presence. And I think the workshop is closed. Thanks a lot to all the speakers and to all the people. And a big applause to all of you. And over. Thank you. Let's go for lunch.
Thank you, guys. Thank you, Santiago.
Thank you, Nestor.
Thank you. Bye-bye.
We speak. Bye.
Thank you. Bye-bye.
Ciao, Santiago.
Ciao, Claudio. Thank you, Claudio.